Good morning, dear teachers and the students who are on the call. You are most welcome for our O-Level Virtual Mathematics Seminar 2026. And our theme for this year is Competence-Based Mathematics, Connecting Learning to Real Life Applications. We want to thank the Ministry of Education and Sports and the partners, Renew UICT, and the Holistic E-Learning Platform for making this session very possible. Our agenda is going to run as follows. We have had a session on what REN is. We are going to go into the opening prayer, and then we shall ask schools through the chat to type in the name of your school and where you are joining in from, and then the number of students that are attending the session. You just tell us that this is Rena College, Mayuge, and these are the number of students that are into the seminar. Then from there, we shall have the official opening of the session from the Principal Education Officer from the Ministry of Education and Sports. So allow me now to invite Mr. Jacob. Mr. Jacob, you can unmute and lead us in a word of prayer. Okay.
Good morning.
Yes, good morning.
My student wanted to lead us in a word of prayer.
Okay, it is well.
Okay. My name is Kaggwa Martyrs, and I'm going to give you a word. Okay, humble yourselves for us. Oh Lord Father, we come before you this early morning, for you've done so much great things in our lives. Oh Lord Father, we put our education into your presence, for you are so great in our lives. You've enabled us to be here this early morning and given us a gift of life. This is so great, and we don't know how to thank you, Lord Father. In Jesus' name we pray them.
Amen.
Thank
Thank you so
This
much.
is Maryland High School from Kampala in Masaja village.
Okay, thank you so much, teacher, for the word of prayer from the student, and thank you so much, Maryland, for connecting for the session. We want to welcome each one of you. Thank you so much for taking time to join the session. We have shared the seminar items in the chat, and we are going to ask you to have them in case you have already printed them for the students. That is fantastic. Thank you so much. We want to ask schools that are going to be presenting to type in the chat, but also you can rename yourself with the item you are going to be presenting. We have already given out some items to some schools that were able to apply, and those are the schools that are going to be the first to present, but later on we shall have other schools present during the session. I want to ask the teachers on the call to type in the chat where you are joining in from, and then the number of students that have joined the session. Type in the name of your school, and then such that we can know which people are attending the session. We are also requesting that you take some photos when the children are seated in those main halls where they are, and then you share with us the photos on WhatsApp. I'm going to share a number that you can share the photos on, such that now the country may know that very many schools, and we have schools that have embraced the technology. At this point, allow me now to welcome the Principal Education Officer from the Ministry of Education and Sports to officially open up the session and talk to us. Mr. Ronald, you are most welcome.
Thank you, Mr. Kaziba. I hope you can hear me from where you are.
Yes, Mr. Ronald, you are very clear.
Good morning, dear students. Good morning, teachers, and any of the administrators who might be joining in. It's a pleasure to see you again after almost a year, because we've been doing this for the last about 7 years, and we are happy to continue working with the schools to ensure that we close the learning gap. As mentioned, my name is Ronald Dungu. I'm a Principal Education Officer at the Ministry of Education and Sports in the Government Secondary Department. And I'm excited that once again, we are joining together as schools. I want to thank the head teachers and the teachers for supporting you, the students, and making sure that we can connect with you online and talk to each other. As a ministry, we cherish collaboration, and we really want to see that the schools collaborate together. And we try to discourage that competition, which is not helpful, which will not lead us to greater heights. The Ministry of Education, through the Uganda Secondary Schools Education Expansion Project, provided laptops, projectors, and projector screens to about 1,400 secondary schools. And the reason for that was to enable such collaboration across schools within one district, collaboration across schools across the country. And that is what we are trying to do, to see that we utilize technology to close the learning gap. So I want to thank all the schools that are joining in today and those that will join in tomorrow, because we know that our friends from the Seventh-day Adventist faith cannot join us today. So we come back to this session on Sunday at 2 p.m. to welcome the other schools that cannot join in today, and those of you who will be able to come back tomorrow to present. We want to hear from you as students, but beyond this, we also have learning sessions that we run for 2 weeks. Mr. Kaziba will talk about that. And every day from 4:30 p.m., we should be coming together subject by subject, the different subjects, so that we can now listen in to the teachers and try our level best to close the learning gap. So this is all about closing the learning gap and working together to make sure that we connect to each other. I can see schools from Kanungu, I can see schools from West Nile, I can see schools from the center, and that means the whole country can be connected and working together on one platform. So I want to thank everybody who is joining in this morning. I want to thank you, Mr. Kaziba, and your team for making this successful. And I know that we are going to enjoy the day. I'll be here most of the time to listen to the presentations from the learners, because I'm interested in hearing how you speak mathematics and how you think mathematically. With those few remarks, I want to declare this session open and wish you the very best. Thank you, and over to you, Mr. Kaziba.
Thank you so much, Principal Education Officer, for the opening remarks and for officially opening the session. I'm going to share my screen briefly, and then I will invite in the first school that is going to be presenting. So I'll ask Rena College to be preparing, because you are going to be the first school to present to us item number 2. In case Taibah is already on the call, they will be presenting item number 1. Then we have Uganda Martyrs Centenary School, Kangulumira. Hope you are already on a call. Gombe, kindly prepare. So that's how we shall be running the session. such that we have different numbers discussed during the session. Allow me now to first share with you briefly that our mathematics paper is composed of two sections. So we have the first section that is compulsory, and section A has number bases, fractions, percentages, numerical concepts 1 and 2, working with integers, ratios, and proportions. And we want to ask the students that as you are preparing for this construct, as you are preparing for this section, there are some concepts that you need to know. That under number bases, do you know how to convert from one base to another? When you are working with integers, do you know how to write from figures to words or from words to figures? Now, in item 1, under ratios and proportions, here the major part or the major area that is always examined under ratios, here it is mainly about sharing. When you look at the items under ratios, here we shall mainly focus on sharing. Now, when it comes to item number 2, these are the different topics that you are going to be meeting under the second item. I want to bring to your attention that it is not always linear programming. Any of these items, any of these topics can be set under item number 2. But here you can as well find proportions under patterns and algebra. Why? Because here under proportion, this is where we look at the direct and indirect proportion, or what we call the inverse. So when you are preparing for item number 2, you should be able to expect something related to direct and indirect proportion, much as ratios and proportions can cut across everything. Then when it comes to item 3 and 4 in section B part 1, these are the topics that we need to prepare for. And then when it comes to the last item, item 5 and 6, these are the different areas that are always examined. What does it mean? Remember, a scenario can contain 1 or 2 or more than that of the given topics, meaning that now you need to be able or well conversant with almost all the topics such that you can be able to respond to the scenario very well. Now, those are the few things that I wanted. And when you look at the seminar items that you were able to receive, you will notice that those seminar items contained those areas that we wanted you to know about. In case your school has not yet received the items, we have shared the items in the chat, and these are the items that I'm displaying on the screen that we are going to be discussing. So these are the items that we are going to be discussing throughout this session. Okay, so these are the items we are going to be discussing. I will reshare them in the chat such that you can be able to access them. Allow me at this point to invite Rena College to take us through the first item. Rena College, kindly unmute, and then you run us through the item you have prepared for.
Good morning to you all. This is Mwesba Jonathan from Rena College, Marige, presenting scenario 2 in the questions of mathematics seminar. And it goes, Christine is a poultry farmer who keeps 1,000 layer birds. During a routine visit to a cow-days company agent, she received the feed formulation guide shown on the poster provided. Figure 1 shows the formulation guide for layer concentrate. At the time of receiving the guide, Christine's birds were 13 weeks old. She intends to prepare feeds according to the recommended formulation for birds at that stage of growth. Christine has bought a full 50-kilogram bag of concentrate and would like to use it all while maintaining the recommended feed mixture. Each bird consumes 90 grams of feed per day. Christine wishes to plan her feeding program effectively so that she can determine when additional feed ingredients will be required. Due to the increasing number of birds on the farm and her plans to expand production, Christine intends to construct a larger poultry structure. The plan of the proposed structure was drawn using a scale of 1 to 50. The area of the structure on the drawing is 96 centimeters squared. Before construction begins, you would like to know actual floor area of the proposed structure. Thus, using information from the feed formulation guide and appropriate mathematical methods, Part A, support Christine in preparing the required feed mixture using the entire 50-kilogram bag of concentrate while maintaining the recommended formulation for her birds. And here we shall find the amount of feeds obtained when mixing a 50 kg bag concentrate. For us to know here, we shall base on the scenario, based on the age of the birds, where the scenario was 13 weeks old, and in the formulation guide for layer concentrate, the 13 weeks are in the range of 11 to 17 weeks, which is the developer stage. So you shall use the concentrate in a ratio of 5 kilograms to mix 100 kilograms according to the formulation guide.
Excuse me, Rena College? Okay.
Excuse.
Yes, may I ask that you share the slide very well? You can put it in the full view such that schools can be able.
Okay. Is it clear now?
Not yet. You have instead removed it.
A moment. So screen. How is it now?
We are not able to see your screen. Okay, I think it is coming on. You can now share the slides. Okay.
Is it seen?
Yes, then you can take us to item 2.
So I was at the task part A. Item 2. That is item 1. Item 2.
Okay.
Part A was saying using information from the feed formulation guide and appropriate mathematical methods at base. Support Christine in preparing the required feed mixture using the entire 50 kilogram bag of concentrate while maintaining the recommended formulation for her birds. And the birds, which are in the scenario were 13 weeks old. And according to the formulation guide, 13 weeks old are in the range of 11 to 17 weeks, which is in the developer stage. So in the developer stage, we find the concentrate of KCl5 having 5 kilograms to mix 100 grams. So I shall say 5 kilograms are equivalent to 100 grams, about 1 kilogram. How many kilograms will mix the feeds? How many 100 kg concentrate mix the feeds? Shall say 100 kg be equivalent to 100 over 5, where I shall have a ratio of 100 kilogram concentrate to 20 kilogram feeds. And after having the ratio, we shall be able to find the number of feeds which will be mixed from a 50 kilogram of concentrate, where I shall say if 1 kilogram is equal to 20 kilograms of mixture, how about 50 kilograms of concentrate will be equivalent to 50 kilograms times 20 kilograms of the mixture, where I shall have the total amount of the mixture of feeds being 1,000 kilograms. So we shall have the answer, where I shall conclude and say, therefore, Christian will prepare 1,000 kilograms of feed mixture using a 50 kilogram bag of concentrate while maintaining the recommended formulation for the birds. That was task part A. Allow me to give the opportunity to another presenter to present part B.
Good morning. This is Kaggwa School from Rena College. I'm taking you through the part B there. So, the part B question says, advise Christine on when she's likely to require additional feed ingredients for the birds. So here, they told us that each bird consumes 90 grams of feed per day. And they already told us here in the beginning that Christine keeps 1,000 birds. So to get the feeds, to get the grams of feeds that are consumed by all the birds in total in one day, we shall get the 1,000 birds times the 90 grams of feed. And that will give us 90,000 grams. So that means that in one day, the 1,000 birds feed on 90,000 grams of feed. But then the feeds we have are in kilograms. The total feeds we have are in kilograms. So we shall have to first change the 90 grams to kilograms, and then we divide them. Since we have the total grams of feeds that are taken by the 1,000 birds per day, we shall have to first change them to kilograms so that we divide them by the feeds that we have in order to get the days that these feeds are going to be consumed in. So we all know that 1,000 grams are equal to 1 kilogram. So how about 90,000 grams? So 90,000 grams will be 1 over 1,000 times 90,000, and that will give us 90 kilograms. So after getting the kilograms that are fed per day, we are going to get the total we shall get the total grams, the total kilograms divided by the kilograms that are fed per day. Here it is. So that means that, so here we shall say in one day, the birds feed on 90 kilograms. So that means that 90 kilograms are fed in one day. Then how about the 1,000 kilograms that are present for Christine? So we shall get the 1,000 kilograms divided by the 90 that are consumed in one day to get the number of days that are going to be that this total is going to be consumed in. So that will be 11.1. And that will be approximate to 11 days. So there we shall conclude that therefore, Christine is likely to require additional feed ingredients for the birds after 11 days. And that is it. So, let me invite somebody else to take us through part C.
Good morning, everyone. My name is Fairmont from Rena College, and I'm going to take you through part C of item 2. And it is determine the actual area of the proposed poultry structure in square meters. And you can get this from our last statement in the scenario, which says that due to the increasing number of birds on the farm and her plans to expand production, Christine intends to construct a larger poultry structure. The plan of the proposed structure was drawn using a scale of 1:50. The area of the structure on the drawing is 96 centimeters squared. Before construction begins, she would like to know the actual floor area of the proposed structure. Remember, well, in the last statement, they gave us that one, according to the scale, that 1:50 is our scale. Since the actual flow of area was big, so we decided to use this as the scale in this ratio. We are given the scale as 1 centimeters squared is equivalent to 50 centimeters squared. So this implies that the 96 centimeters squared is the same as 96 centimeters squared times what? Times 50. Because 1 centimeter squared is equivalent to what? 50 centimeters squared. So this will be 96 times, we shall square that 50. It will be 96 times 2,500. Yeah, we shall get 200. It is 240,000 centimeters squared. And you know well that 1 meter is equivalent to 100 centimeters. What about 1 meter squared is equivalent to what? Is equivalent to 10,000 centimeters squared. So this implies that 1 meter, 1 centimeter squared is equivalent to 1 over 10,000 meters squared. So this will be 240,000 centimeters squared is equivalent to 1 over 10 centimeters squared times 240,000 meters squared. If we cross, we shall get 24 meters squared. Since because they wanted our answer to be in square meters, so therefore the actual area of the proposed poultry structure will be 24 meters squared.
Okay.
That is from Rena College, Mayuge.
Okay, thank you so much, Rena College. In case you have any questions, kindly raise up your hand. We shall take on 2 questions. You can even place you can place the questions in the chat. In case there is any question, kindly, okay. Let me first pick on a hand. Yes, Rabban.
Good, good morning, members.
Good morning.
My question is, I see here they have given us they are saying that the given scale is 1 centimeter is equal to 50 centimeters squared. Is that square is it on centimeters or it is on the area? I don't understand there, master.
It is squaring the number, that of 50.
It's not on the centimeter.
It is on both there on centimeters.
Oh, because I see here you have said that 96 centimeters squared is equal to 90 times 50 squared without a unity for centimeter.
It's the area. Because we said the unit here. That becomes because the area. We have just eliminated the units that at the end to adjust in calculations. Yeah,
Okay.
they were calculations.
Okay, thank you.
You're welcome.
Okay. Yes, Gombe High School. Okay. I think we have failed to. Okay. Thank you so much, Rena College. Allow me to make a comment on the presentation. I'm going to share my screen and then I make a comment on item 2. Now, dear students, whenever you read the item, 1, always identify the concept within the item. What concepts are within the item? Number 2, identify what is the problem within the item that you must be able to solve. When you look at the item, you need to identify what is the problem that I must be able to solve at the end of the day. And before you leave this item, always you must ask yourself, have I been able to solve the problem that was within the scenario? Now, when you look at the item we are dealing with, this particular farmer had these layer buds. But one of the areas that I want to emphasize is the problem that we must be able to solve within this. When you look here, there is an element of ratios. And one of the key things you needed to identify is that they told that Christine's births were 13 weeks. So that means that you need to be able to look at the image being provided and identify that 13 is within here. So meaning that this is the formulation that this particular farmer had to use. So like Mayuge told us that was within the developer stage. However, when you read the scenario further, they told that after receiving the guide, Christine's births were 13. She intends to prepare feeds according to the recommended formulation. What does it mean? That here, Christine has a puzzle. Christine wants to have the formulation. However, when you look at the formulation, you note that the formulation that has been given to Christine is only for 100 kilograms. And what does Christine want? Christine wants to mix the full 50 kilogram bag. Now, when you, like Mayuge was able to calculate for us that the total feeds that Christine can be able to mix is going to be 1,000 kilograms. But knowing what you are going to obtain at the end of the day doesn't solve the problem, because the problem that we are looking at is that how much of the concentrate do we need to mix? That here they have told you that is going to be 50. What about the broken maize? What about the maize bran? What about the soya cake? What about the limestone? Meaning that now you need to support this farmer to know how much of each of those ingredients he is going to put, such that he comes up with the 1,000 kilograms. So that is something that that Mayuge did not bring out in the calculation, because we need to support the farmer in preparing the required feed mixture. But as we were only able to get the 1,000 kilogram, which is the total that he's going to get. But what about each of the ingredients? What is he going to be putting in there? So that is the component that we need to have when it comes to part A. So Mayuge, you prepare to give us the response on how much we are going to be putting for each of the ingredients. Part B was responded to well, and part C was responded to well. But for part A, we need to go deeper and support this farmer in being able to mix the feed using the entire 50 kilogram bag. Now, number 2, dear students, make sure that whenever you are replying to this item, you respond back. Don't just write your answer. Now, like here, where, let me say, you have obtained your answer as 24 meters squared. Do not just stop there. Go on and respond back that the actual area of the proposed poultry structure is 24 meters squared. That is responding. You are responding back to the item. Do not just calculate and stop there, but go back and respond. You responding back to the item is going to earn you a score for responding to the item, and clearly show you're working for whatever step you are working on. Clearly show you're working in a very good format, vertically going downwards. So allow me to hand back the mic to Mayuge, and then Mayuge, you tell us, what about for each of these ingredients? What shall the farmer need such that he can mix the 1,000 kilograms that he has to mix? Yes, Mayuge.
So to get the amount of each ingredient, we shall have the 50 concentrate, we divide it by the 5 kilograms of KCl, I shall have 10, and we shall go back to the formulation guide, shall be multiplying 10 by each kilogram. In the developer stage, I shall have the KCl 5 times 10 shall get 50. Broken maize, where we have 56, shall have 56 times 10, where we shall get 560. The maize brand shall have 26 times 10, I shall have 260. Soya cake, we shall have 11 times 10, I shall have 110. Limestone or shells shall have 2 times 10, I shall have 20. And after adding the total of KCl, broken maize, maize bran, soya cake, and limestone or shells shall have the total of 1,000 kilograms. Thank you.
Thank you so much, Mayuge, for that wonderful presentation. Yes, so like they have told us, we shall get our scale factor, which is 10, and then we multiply. So do not forget now at the end of the day to make a conclusion for what each of the ingredients that will be needed for the presentations. Okay, thank you so much, Rena College, Mayuge, for the wonderful presentation. Okay. There is a question. Let me invite St. Mary's Kakumilo. Okay. Palabek, is it a question? As Taibah, you share your screen. Okay. Okay. Over to you, Taibah.
So, good morning, everyone. My name is Jeremy Agaba, the first representative from Taibah International School. I hope all of you can hear me.
Yes, we
Just
can.
okay.
We can.
Okay, so us as Taibah International School, we shall be discussing for you item 1, which is under the theme of numbers. So I'm going to start by reading for you people item.
The Agricultural Club of a secondary school has harvested 50 tomatoes from the school garden and plan to sell them to the surrounding community during the school market day. The club members proposed selling the tomatoes in groups of 7 tomatoes. Each group sold at 5,000 Ugandan shillings. However, the agriculture teacher suggests that the tomatoes should instead be sold in kilograms. After weighing the tomatoes, the members found out that 1 kilogram contained 4 tomatoes, and each kilogram would be sold at 3,500. The club also agreed that 60% of the money obtained from the sales would be reinvested into the school garden program, while the remaining amount will be shared equally among 7 club members. All the tomatoes harvested were sold during the market day. The club harvests tomatoes after every 5 days, while the community market day is organized after every 7 days. On the 27th of May, 2026, both the harvesting and the marketing day happened on the same day. Thus, advise the club on the better method of selling the tomatoes. Give your reason for the answer. B, if the club uses the better method of selling, determine the amount of money that will be reinvested into the school garden project. Then the second one, the amount of money each club member would receive. C, determine the next date on which the harvesting and the market day will happen, again on the same day.
No. So I hope all of you have been able to see the item that we have been able to do. So we are going to be answering part A, which states advise the club on the better method of selling the tomatoes and give a reason for your answer. So in the scenario we have been given 2 methods of selling the tomatoes, which is first, the club members propose selling the tomatoes in groups of 7 tomatoes, with each group sold at 5,000 shillings. So first, we're going to find the total amount of money that would be made if all the tomatoes were sold in groups of 7, each sold at 5,000 shillings. So the total amount of tomatoes were 50, which we were able to divide by 7 in order to get the number of groups. Then we got 7 groups remained at 1 tomato. So then we multiplied that by 5,000 shillings in order to get the total amount of money that we would make from selling the tomatoes in groups of 7 tomatoes. Has everyone been able to understand that? Then for selling in kilograms, we were also able, in the scenario, it said the agriculture teacher suggested that the tomatoes should instead be sold in kilograms. After weighing the tomatoes, the members found out that 1 kilogram contained 4 tomatoes. So now, if 1 kilogram contained 4 tomatoes, we're able to divide the 50 tomatoes by the 4 contained in 1 kilogram to be able to get the 12.5 kilograms for the entire 50 tomatoes. Then in order to get the amount of revenue, because each of these kilograms were to be sold at UGX 3,500, we multiplied that by 12.5 in order to get UGX 43,750. So in conclusion, therefore, the club should sell the tomatoes in kilograms because it gets more money, which is UGX 43,750, than selling them in groups of 7 tomatoes, which is UGX 35,000. So I am going to pass on to another member of my team to do part B, Roman numeral 1.
So, good morning, everyone. My name is Fra Elizabeth, the second member of the group. Now, for part B, item 1, we're going to find the amount of money that would be reinvested into the school garden project after we determine the best-selling method. We have already determined the best-selling method, which is kilograms. So, from the scenario, we have to find 60%. So you get the 60%, multiply it by the amount of money you got from the better method. And after you multiplying, you'd get shillings, you'd get UGX 26,250,000. That would be their money reinvested. Therefore, the amount of money to be reinvested into the school garden project is UGX 26,250.
So I hope everyone has been able to understand that. So I'm going to move on to Roman numeral 2. So Roman numeral 2 states they want us to find if the club uses the better method of selling, they want us to determine the amount of money each club member would receive. So first of all, we have to subtract the total amount of money that we would make from the better selling method from the amount that is supposed to be reinvested into the school garden project in order to get the total amount of money that remains so that we can share it among the 7 members. So we got 43,750 Ugandan shillings and subtracted it from 26,250 Ugandan shillings in order to get 17,500 Ugandan shillings, which is the amount remaining that is supposed to be shared among the 7 members. So then we proceeded to divide the 17,500 Ugandan shillings among the 7 members in order to get 2,500 Ugandan shillings. So therefore, each member of the club is going to receive approximately Ugandan shillings, 2,500 shillings. So I'm going to pass on to another member of my team to answer part C.
Okay, good morning, everyone. My name is Shima Habib, and I'm the 3rd member of the group, and I'm doing part C, determine the next date on which the harvesting and marketing day will happen again on the same day. So this is basically asking us to use LCM. So the harvesting cycle happens every after 5 days and marketing day cycle 4 days. So you find the LCM of 5 and 4, which is 20. So therefore, both the activities will happen every 20 days. So then they said, on 24th May 2026, both harvesting and marketing day happened on the same day. So May has 31 days. So from 24th May to 31st May is 7 days. So the remaining is 20 minus 7, which is 13 days. So count 13 days into June, which makes it 13th June 2026. Therefore, the harvesting and marketing day will happen again on the same day on 13th June 2026.
I hope everyone has been able to understand item 2. This has been Taibah International School. Thank you so much.
Okay, thank you so much, Taibah. We have some questions from the different schools. So kindly, you're going to take them on. I'm going to start with Kihi High School. Okay. Kihi High School, you can ask. Okay. Rena College.
Why? Record.
For the question we have for part A, where we had selling in groups, they did not consider the remainder, which is correct. But on part B, where they were selling in kilograms, they considered the remainder, and yet the remainder was not making up the kilograms. Why did they consider it? Yet it was just the remainder of the groups of the kilograms of 12.
Okay.
So
Taibah,
okay,
go on.
okay, thank you so much for that question. So the reason why we considered the remainder in
Yes.
when we were calculating the selling in the groups of the 7 tomatoes is we didn't, sorry, the reason why we didn't consider the remainder when we're calculating selling groups of 7 tomatoes is because the 1 tomato that remained is negligible. It does not have, it is not even half of what is needed to create one group. Hence, it cannot be measurable to a specific amount that is needed to be sold. Then for selling in kilograms, the reason why we continued to consider the kilograms is because the amount in kilograms can be calculated mathematically.
Is it possible to also consider the remainder, and yet they were only selling in kilograms?
The parameters had been set in the question, so we couldn't go beyond them.
Because the scale says it is only 1 kilogram to be sold at a given amount, but they did not give the remainder. Oh, they can also sell halfway. So I just need some clarification there.
So basically, when we talk about a group, the parameters have been very set, like you cannot go beyond a group. And when you talk about a kilogram, 1.5 kilograms exist. You cannot say half a group, yet the parameters for a group have already been set. But you can say 1.5 kilograms because the parameters for a kilogram have been set. So considering the remainder of the maybe negligible kgs, when we were calculating the selling in kilograms was correct because the parameters for kilograms allowed it to happen, but the parameters for a group did not allow a negligible 1 tomato to be added to the amount.
So you mean you can sell also the remainder in halfway, isn't it?
Yes.
But according to the scenario, they did not say that we can sell in halfway. It was only in kilograms.
Like I said, the parameters for a kilogram are dictated. Okay, a kilogram has the ability to exceed the parameters of a decimal point, whereas a group, the parameters have been set to one group. So we cannot exceed those parameters. But for a kilogram, we can exceed and touch decimal points.
It's true, but we usually follow the scenario. The scale given is only for kilograms, that they say 1 kilogram contained 4 tomatoes, which were only to be sold in kilograms. They not say that they can also sell the remainder.
But at the end of the day, the parameters of the fact that it is a kilogram allow us to enter the decimal point.
It's true they allow us, but we usually follow the standard which is given. I wish they had said that it would also be sold halfway or quarter, we should consider the remainder. But since it was not talked about, we cannot consider the remainder. We only take 12 kilograms because the amount is only for kilogram. They will not give us the amount of halfway or quarter. So for me, I think you just take 12 times the amount of 1 kilogram because it shall only have 12 kilograms and not having an amount of a half or a quarter. Thank you. You know. Yeah. That's why.
Sorry, I was saying that when you look at the scenario, I want you to check out on the second paragraph. It said that all the tomatoes harvested were during the market day. Let me hope you saw that statement that all the tomatoes harvested were sold during the market day. So,
Yeah,
Taibah, you have used that statement to support
it
the
is,
discussion.
it is true. It is true they were all to be sold, but when you say all they were to be sold, it means you also take the remainder of the groups because it would also be sold at the market day. If you just say they were all to be sold.
Bro,
It would be correct, yes, to take the remainder, but at the end of that day, the remainder is very negligible. It's one tomato. If it held weight or if it was like 3 or 4, at least a half of what a group is supposed to contain, we would consider it. But it is negligible. It is one.
So, in summary, you cannot sell one tomato.
Excuse me, the parameters that we use to sell are 7 groups. The parameters that we use are 7 groups. If we have decided to use 7 groups, I can't come from 7 groups and then I give one specific person 1 tomato. I give them 1 tomato. But if I look at it in terms of kilograms, a scenario, you're not going to go to a shop because math is about it being applicable in real life. You're not going to go to a shop and they say they sell 8 tomatoes. And then out of all the 8 tomatoes, since they want to sell all the tomatoes that day, they're going to sell me 1 tomato at the exact same price. Are you understanding?
Yeah, so it means also in kilograms, you only take 1 kilogram because they'll sell based on 1 kilogram. They cannot take the halfway or the quarter.
Okay, I want you to look at this from a very logical kind of point of view. If you go to a shop and they're selling something in groups or in kilograms, you cannot ask to buy an individual thing. You cannot ask to buy the 1 tomato because that's not the offer they are giving. They are giving it to us in groups. And them themselves, they wouldn't sell to us an individual thing because the offer they are giving us is in groups. So that's the parameters they have set. For kilograms, you can enter decimal points because that's the parameter of kilograms themselves. But for groups, if we're selling in groups and we have one negligible remainder and the parameters have been set to remain within groups, we cannot consider
So it means also in kilograms. When you go to the shop, when they are packed only in kilograms, are you able to ask for a quarter or even a half when they are only packed in kilograms?
Yes, because you can calculate, you can very well weigh a half a kilogram. You can very well weigh.
When they're only grouped in kilograms, not halfway or a quarter.
You cannot compare kilograms and groups because a kilogram is a standard unit. A group is something very negligible. You cannot consider it.
That's what I was trying to tell you. If they're selling in groups, they only sell in groups, whereas when they're selling in kilograms, they only sell in kilograms.
Could you kindly repeat?
When you are selling in groups of 7, you have said they don't give you any tomato which is not in a group, so?
Yes.
It means also when you are selling in kilograms, they will only combine 1 kilogram containing 4 tomatoes, not so?
No, at the end of the day, the 12.5 kilograms can be calculated, can be weighed. We cannot weigh a group. Okay, like I was saying, you cannot compare a standard unit to a group. At the end of the day, you cannot compare them. Okay, because a standard unit has parameters it can exceed, whereas a group has set parameters it cannot exceed.
It's true in kilograms, it is standard, but the only cost we were given is only 1 kilogram, not a half or a quarter. So if you are basing on the standard quantities in the scenario, we shall only consider 1 kilogram and consider 7 tomatoes in 1 group.
I think you're looking at this from the point of view you're looking at this from is
the only problem you are putting in is because you are just comparing it at most at the average in the real life stations only, but you have forgotten that the cost you are given in the scenario is only 1 kilogram.
You're failing to understand where I'm going with this. By the fact that they said kilogram. They allowed us to use all the parameters and rules that come with the virtue of a kilogram. Hence, we have the right to use those parameters and to use those rules that come with using the standard unit of kilogram to our advantage, hence allowing us to enter the decimal point, because this is something that can be standardly measured. You understand?
Yes, true.
I can't hear you. I think you're muted.
Okay, thank you so much, Taibah, for the discussion. And like you have said that math is real life. So always you need to relate it to real life. What happens in real life? When you go to people selling in the market, you'll find that in real life, you need to apply the knowledge you learn. When you go to, remember these farmers or these students had harvested. So mean that whatever they had harvested, it is within their means. So when, yes, okay. So for a half a kilogram can be considered in real life. When you are answering, do not only base on the book knowledge, but also ask yourself, how does it, all these items that were being said have real life applications? So always you must relate to real life. Next time, even they may ask you, because for a group you may not measure but can be counted. They can be counted. So okay, so here we shall consider the half a kilogram, because in real life it can be measured. You can go to the shop, you can go everywhere and have it in a half a kilogram. Remember, these students have gone to the market day, and if all the tomatoes had to be sold, then that means that also the half a kilogram can be sold, because even when you look at the money for a half a kilogram is realistic in real life. Then maybe the one tomato that remained, then that one you can say that maybe that one can be given out as a bonus for someone who has bought very many groups. Okay. I think I want to take on one question from Kasese, and I'm going to ask Gombe, uh, Gombe to prepare, as well as Uganda Martyrs Centenary to prepare. Kasese.
Thank you very much. Good morning. My
Good morning.
concern was on item 1 part A, where they claim to have sold the tomatoes in 7 groups and they forgot the remainder. Therefore, they would have found the cost of 1 tomato and then they add it on the other one to get the total money that will be given unto them.
Okay, Kasese, what could be the cost for 1 tomato?
Then you divide the amount of 7 tomatoes, the cost of 7 tomatoes by 7. Yes, you get the amount of 7 tomatoes. Okay, you divide it by 7, getting a total of 1 tomato.
Okay, over to you, Taibah. What do you have to say?
Could she kindly re-elaborate her question, please?
I was saying, since 7 tomatoes in one group, they can be sold at 5,000. Therefore, you find the cost of 1 tomato by dividing that 5,000 by 7. Then,
Okay. Thank you so much for that insight. But yes, if we were to do a question in that format, yes, that would be 100% correct. But the parameters that the question had set claimed that each of these tomatoes were to be sold in groups. They did not tell us to go beyond the parameters they had set and enter into the individual price of each tomato. So yes, that would be correct. But at the end of the day, what the question wanted us to do was to calculate for the groups, not for individual tomatoes.
but remember, in that scenario, you were given to
find the cost of all the tomatoes that have been harvested, and therefore they will all be sold. Then you have to find the cost of one tomato that will be added on the other one. And then you sell all the tomatoes.
I think you have kind of I'd like to say an oversight in the question. The question did not say find the cost of all the tomatoes that are going to be sold. It told us to advise the club on the better method of selling the tomatoes. Now, when they say advise the club on the better method of selling the tomatoes, we only do that under the parameters they have set in the scenario. We only go with what the scenario has given us. We do not add our own ideologies. We do not add all what we know about math. Yes, that can be done. The 5,000 shillings can be divided by 7 in order to get the price of each tomato. But no, that's not what has been given to us. That's not what the scenario told us to do. It told us to sell the tomatoes in groups, and that is what we have done. Thank you.
But remember, you are told to sell all the tomatoes that have been harvested. Okay, thank you, but correct.
Okay. In case of any other questions, kindly you can have those questions put in the chat. But I want to ask you, dear students, always refer to real life method. The item required you to compare and see which approach would be the best for you to use such that you get the best selling approach you can use. So from the item, we would conclude that the best item is selling these things in kilograms, because whatever when you use that approach, you can notice that you'll be able to get more revenue compared to the other one. Okay, then someone is asking, can't we get a formula of getting the next date like using the mode of finite system? Yes, you can use that one. There is no problem. But I'm also going to ask the students that you always, when it comes to time and dates, you can refer to your knowledge that you learned in during the lessons on time and timetables. But I want to bring two concepts at hand as you deal with that. Number one is the concept of my screen's on, is the concept of highest common factor and lowest common multiple. Many times we do confuse the two things. Sometimes you may fail to know where am I going to use HCF and where am I going to use the lowest common multiple. Whenever it comes to the highest common factor, dear students, that one occurs when you are grouping things, when you are trying to divide things, when you, let me say you want to invite people to come to a function, but you don't know how many people you should invite such that things can be shared equally. Now, such a concept goes under HCF. Now, whenever you read the scenario and you check out that it concerns things of dividing, it concerns things of sharing, then that means that the knowledge you are going to apply is the knowledge of HCF. However, when you find things that are concerning things that are going to occur again, things like, let me say, events that are going to occur again after a given period of time. When it comes to things like running, when they should be at the same point, then you need to know that the concept you are going to apply is the concept of LCM. Now you need to know, when am I going to apply HCF? That's when it comes to dividing. When it comes to things of sharing, when am I going to use LCM? That one will come for things that occur again after a given period of time. Now when it comes to dates for the month, then you can use the idea. I know during your childhood, your parents used to show you the idea of how you can use your hands to count how many days are within a given month. So many times when they put months, you need to know this month has how many days. This month has how many days. So you can remind yourself that when it is January, January is the one that is always found at this top, that it has 31 days. Then you know that this month, that when it is up like this, those are 31 days. When it is down, those are 30 days. Such that now you do not fail a question because you have failed to get the number of days within a particular month. But I'm also going to ask you that when you are calculating something, always have a simple heading to show what are you calculating or what are you finding out from the scenario. Okay, thank you so much once again, Taibah, for the presentation, and thank you so much for the discussion or the schools that have been discussing. I'm going now to invite Kangulumira. Kangulumira, hope you are set to take us through the second item, Uganda Martyrs Centenary. Kindly unmute. Uganda Martyrs Centenary, you are our next discussants.
Wow.
Okay. Uganda Martyrs, we are getting some feedback, noise. So I will request that one of the microphone, you can disable it in the other room.
Kendeza.
Yes. Yeah. Kindly have the other microphone. Okay. Yes. Uganda Martyrs, we
Bring
can
the
start.
microphone. All right. Good morning, Mr. Kaggwa and the colleagues, even all other schools. This is Uganda Martyrs Centenary Secondary School, Kangulumira. We are to take through you in item 9, that is data and probability.
Hi everyone, my name is Joan Jacinto Kusia, Uganda Martyrs Centenary, SS Kangulumira, data and probability item 9. Let me first read the scenario so that we can analyze the scenario. It's saying that due to the increasing number of road accidents associated with the mechanical failure, the Ministry of Works and Transports intensified vehicle inspection exercise in selected regions of Uganda. The ministry is particularly concerned about vehicles operating in the multiple defects because such vehicles are considered highly risky to road users. A team of engineers was assigned to analyze inspection findings from one region after concerns were raised about the condition of vehicles operating along the highways. According to the ministry's guidelines, a new inspection center should be only considered if less than a half of the inspected vehicles are found with one defect. During the inspection exercise, 94 vehicles were randomly selected and inspected for faulty tires, faulty steering systems, and faulty work bodies. The inspection findings showed that 34 vehicles had faulty tires, 40 had faulty steering systems, and 29 had faulty work bodies. Some vehicles were found with more than one defect. In particular, 7 vehicles had both faulty tires and steering systems. 6 had both faulty steering systems and work body, while 11 had both faulty work body and tires. The engineer also established that 11 vehicles did not have any of the 3 defects under investigation. There is our task saying that using a suitable presentation, support the engineers in establishing the extra number of vehicles that had all the 3 defects. In particular here, we are going to cover data and probability, but the main sector here is it's all about set theory. Here, in set theory, we have three diagrams whereby in set theories, we are more concerned by the universal sets, the union sets, the intersection sets, the complements. It is in this part. At this moment, we are going to first of all summarize all our scenario. I'll start by saying that during the inspection exercise, 94 vehicles were inspected. In this particular, the 94 vehicles which were inspected, that is referred to as a universal sets. Therefore, the number of universal is equal to 94. Remember, when we are in the set theory, we use unknowns. For example, we can say, let the number of this and this be this. We don't use the particular, for example, 40 tires. We don't use the particular one. But we should let the what? The particular sector we are tackling. Here, we are having the scenario saying that the inspection findings showed that 34 vehicles had 40 tires. In this, we have 34 faulty tires. But before tackling that, we are first of all going to let the faulty tires by saying that let the faulty tires
Speed.
faulty work bodies, faulty work. Sorry, it's body work and faulty selling system. B, we shall let the tires to be T, comma, the body to be B.
Just read them and we'll go.
And the selling system BS respectively. Therefore, we are going to summarize our question, whereby number of T, all faulty tires were, that was, let me see, it is 34, equals to 34. And number of sterling systems were 40. And therefore, number of the workforce was 29. 29. Having summarized all this, we shall go to another part where I say that in particular, 7 vehicles had both faulty tires and sterling systems. In this sector, we shall say number of sterling, it is sterling faulty tires and sterling systems, whereby it is number of T intersection S giving us 7. And here it is number of S intersection B, whereby it is 6. And here it is number of B intersection T, and it is 11. But remember, in our scenario here, they are telling us that engineers also established that 11 vehicles did not have any of the 3 defects, meaning that over the inspections, only 11 vehicles did not have any of the 3 defects. Therefore, we shall say that it is all about none, or we can say number of B intersection T intersection S complement is all of, it is B universal T B union T union S complement is all about 11, meaning that none of these were 11, meaning that when we exclude this B, T, and S, the answer is 11. Therefore, with all our summary, we shall be able to draw our Venn diagram. But remember, there are some region whereby in the intersection we shall have, they have not given us, we can also let it and say
Proceed.
Remember, all mathematical diagrams should have headings. We are going to tackle the Venn diagram. We shall say the Venn diagram showing that here we shall start filling in what we have been summarizing, and the universal set was 94, and this was number of V, and this was number of C, and this was number of S. Whereby in our summary we said that number of T is 34, equaling to 34. B is equaling to 29, and S is equaling to 40. But remember, we also have that part of the complement, which was 11. Here we're going to start filling in our sector. But remember, they told us that those vehicles that had faulty selling tires and those vehicles that had faulty selling systems and the faulty tires were 7. Remember, all this region is for both. All this region here, it is for faulty tires and faulty selling system. But they are saying that all this region had 7. Therefore, we should exclude this part here, whereby this part here is just telling us that it is that part whereby we say that T union B union E, T intersection B intersection S. This part shows that all the vehicles had the 3 defects. But remember, all of this, it is 7, meaning that we should exclude this so that we get the value which is here. Therefore, in this sector, we shall have to let. Remember, each and every unknown you put into your Venn diagram, you should indicate it to the examiner that this unknown I'm putting, it is representing this. Therefore, we are going to let and select the number of vehicles.
Just read it.
Let the number of vehicles with all the 3 defects be X. If this is X, meaning that if you want to get the value of here, we are going to get the intersection minus this X, whereby it will be 7 minus X, and here it will be, they have told us that S intersection B was 6. Here is X, here is S, here is B, whereby it was 6. Therefore, it was 6 minus X. And also here, they have told us B intersection T, it is 11. We shall say 11 minus X. Therefore, we've left with these empty regions. Therefore, we can also have to let them so that the examiner knows each and every unknown you are putting in your set. We shall let this one to be A, this one to be B, and this one to be C. Therefore, with all that, we can complete our Venn diagram. Allow me to rub. Here, we are going to start finding the unknowns, whereby we shall start with finding the unknown of A, whereby here we shall say that A, finding the unknown of A, where the unknown of A we shall set 7 minus X plus X plus 6 minus X plus the A equals to 40. Remember, right now we are starting with the that part where the steering systems. So having all this, we can now start solving, whereby a negative will go with a positive and remain with 7 plus 6 minus x plus x.
Just describe it, then you draw a final diagram.
This is 40. We are going to do all this in other sectors. And after there, we shall have to solve and get our unknown of x. If you continue like that, because of time, the value of x will be 4. And after getting the value of 4, the value of x, we shall be able to finalize. After getting the value of x, therefore we shall be in position again to draw the next Venn diagram. Remember, in this set theory, we have to use 2 Venn diagrams. The other one with the unknowns and the other one with the knowns. Therefore, we are going to draw another Venn diagram with all the features, the titles. Here we shall have this. But remember, the value of, let me first do this. This was 94. It was 94. And number of t was 30, 34. Number of s was 40. Number of b was 29. Therefore, this was 11, yeah? With all that, we shall put in what we have found, whereby x, which was here, was 4. And here we got some unknowns, whereby it was 20.
Put them.
When you do that, what? Those workings. Therefore, here the value will be 3. Here the value will be 7. Here the value will be 2. Here the value will be 20. Here it will be 31. And here it will be 16. Then, after all that, we shall have to finalize with the conclusion, whereby the question was saying using the suitable representation, support the engineers in establishing the exact number of vehicles that had all the 3 defects. Therefore, in your conclusion, you shall conclude by saying, therefore, the number of vehicles with all the 3 defects was 4. Accordingly, here everybody has his or her own conclusion. As long as you put a correct conclusion with the number of those vehicles that had all the 3 defects. Thank you.
Part B.
Part B saying, using evidence from the inspection findings, give a recommendation to the ministry concerning the establishment of another vehicle inspection center in the region. Allow me to invite my fellow. Thank you.
Good morning, members. I'm going to take part in part B, which says that using evidence from the inspection findings, give a recommendation to the ministry concerning the establishment of another vehicle inspection center in the region. For this part, requires us to read this phrase, which says that according to the ministry guidelines, a new inspection center should only be considered if less than half of the inspected vehicles are found with only 1 defect. Now we're going to use probability. We're going to say that probability equals number of events over number of sample space. Now the number of events is, they have told us that according to the ministry guidelines, a new inspection center should only be considered if less than a half of the inspected vehicles are found with only 1 defect. Now the vehicles which are found with 1 defect are
Hold the book.
20 plus, I'm going to add them. 31 plus 16. The number of the sample space is the total of the inspected vehicles, which was 94. Then here the total we get is 67 out of 94. Now this occurs with one defect.
Mind about the camera.
Yes. Then you are going to get a half of the inspected vehicles, which will be a half of the inspected vehicles, which is the total, which is 94. Then I hope you are going to get 47 vehicles. Then for this case, in the conclusion, because they have told us that the inspection should be made if the number of vehicles with the one defect is less than the number of cars with one defect, then the conclusion will be
read it just.
Then the conclusion will be that therefore a new inspection center should not be considered because the number of vehicles which were inspected with one defect beyond the half of the inspected vehicles. Thank you. That is the discussion.
Conclude.
Here, guys, as you've seen, it's all about the probability, and they were saying that those vehicles with only one defect, and we've added all those vehicles whereby we've added the steering with faulty steering only, work bodies only, and the tires only. When we are tackling that number, we just use that only part. I know that you are all well conversant with the only part.
Summarize.
Where the part is considering only one defect. Therefore, you add and you get the total, which will be the number of events over the universal, and that was 67 over this one. And therefore, according to the half of the vehicles, the number which we got was beyond. That was all about the set theory. Thank you.
Thank you very much. Back to Uganda Martyrs Centenary. Other questions are welcome.
Okay, thank you so much, Uganda Matters. Let's have some questions. St. Leonard Madu, is it a question?
Good morning, members.
Good morning.
My question is, yes, when you setting the title for the set, he said that mania the Venn diagram showing the data. But for me, my question is, which data they are showing us? I want them to make more clarification to explain about the title. And on the set, they have drawn. For me, I have calculated for the members. They have given us the fault for tires, this steering system, and body worker. So whereby they didn't give us the side whereby for steering only they did not give us, and for the body worker they did not give us, and for tire only are not given to us. So my question is, when I calculated the way I've calculated it, they telling us that they have got 4 only. So let us make more clarification about those.
Okay, thank you for that wonderful question. In my explanation, I say that all mathematical diagrams should have a title, and by all whatever it is our scenario, that is the data. Because they are telling us that the ministry carried out the inspection, meaning that after the inspection exercise, what they collected after the inspection, that was the data. Therefore, even though you put that the Venn diagram showing the data, already the data is in the what? In the scenario. And this thing, it's not all about that the same ideology. No, somebody might have another idea, and I also have another idea. But the Venn diagram title should be just having a title. And when I say that the Venn diagram showing the data, already what is in the Venn diagram, it's all about what is in the scenario is the data. That's why I've just said that the Venn diagram showing the data, because I've summarized all the data which has been in the scenario and placed it in the Venn diagram. And you are saying that 4 only. No, I will say that the number of 4, when you see 4, it just simply means you see even the region where 4 is. Yeah? 4, where 4 is, it's all about here. It's all about the where where the vehicles had the 3 defects, meaning that all the vehicles, the number of vehicles that had all the 3 defects was 4. Therefore, this just symbolizes that this part here, it is the region where all the 3 vehicles had the 3 defects. Therefore, that's all about it. Okay, if you have any other question or I've not elaborated more, you can ask.
Okay, we have Palisa. Palisa? Okay. Light vocational? Light vocational? Light vocational? Ask. Oh. Okay, I'm failing to get light vocational. Lastly, St. John's Secondary School.
Thank you, sir. I need to ask that, was it necessary to look for the probability? Yet the statement was clear, said that if less than half of the inspected vehicles are found with only 1 defect, I need a clear explanation.
Okay, thank you. You are saying that was the probability necessary if the scenario was asking that if the number of the vehicles inspected with 1 defect is less than the half of the inspected vehicles. Allow me to send that question to the person who explained it. Thank you.
The question you are saying is that the probability, for me, what I know, the probability is needed because we want to get the chances for the vehicles with 1 defect, the vehicles that have half of the vehicles inspected. That's all.
Again.
What I'm saying is that we use probability in order to get the chances for the vehicles with only 1 defect, and the vehicles that have of the defects which we inspected. That is it.
Okay, thank you. Okay, so I think we are going to have Mugula as the last school. Then the rest you can put your questions in the chat. Mugula?
Okay, good morning. My question is is that 47 is the answer for task B, because it is clear that the ministry, according to the ministry, the new inspection center can only be created when the number of vehicles who are found with only one defects are less than the half of the total number of the vehicles inspected. So I want them to clarify something. Right? Is that 47 is the right answer or not?
Okay, thank you. But according to the explanation my fellows put across, he has said that we are going to first find the number of the vehicles with only 1 defect, whereby that is the sector for the only part when you, after getting the probability of the
Go back and clarify from the scenario.
of the vehicles with one defect. Therefore, according to the scenario, it's saying that according to the ministry's guidelines, a new inspection center should only be considered if less than a half of the inspected cars are found with one defect. In this, we must be well covered that with a half of the vehicles and the number of vehicles with only one defect. That's why my fellow has put it across very well. He has first find the probability or the number of chances of vehicles with only one defect, which was 67 over 94. This is the probability of those vehicles with only one defect. Here, he wanted to clarify more by finding the number of the half of the vehicles. That's why I say that a half of the vehicles, in order to determine is the number of the vehicles with only one defect beyond the half of the vehicles inspected or not beyond. That's why he has find out in order to clarify his answer whether the number of those vehicles with only one defect is greater than the half of the vehicles inspected. And that's why he has put his conclusion very well that a new inspection center should be not considered because the number of vehicles inspected with only one defect is beyond the half of the inspected cars, meaning that these cars which were inspected with one defect is beyond the half of the number of the vehicles with defects. Therefore, that's all about it. Thank you.
Okay, thank you for your clarification.
Lastly, how did you get 47? Someone is asking.
Okay, thank you. How did I get the 47? Guys, in the question they are saying that, let me relate it to the scenario, because the scenario is saying, according to the ministry's guidelines, a new inspection center should be only considered if less than a half of the inspected cars. Guys, the inspected cars were 94 inspected cars. But they are saying that if less than a half of the inspected cars, guys, this is the same as a half of the inspected cars. The inspected cars were 94, but we should get the a half of the inspected cars. That's why we have come here and said a half of the inspected cars. And the a half of the inspected cars is all about 47. This is the same as, because it's all about that. Why the half, because it is 47. And even though you put it and say that a half of 7, what is it? It will be 7. 47. Thank you. That's how I got the 47. Another question.
Okay, thank you so much.
All right, that's what we had as centenary.
Okay, thank you so much, Centenary, for the wonderful presentation. That is Kangolumira. We are very grateful. I'm going to share my screen a bit, and then I'll make some clarification on a few things. Now, the section that Sentinel has been having is the section of data and probability. And under data and probability, we have statistics, we have Venn diagrams, we have matrices and tree diagrams. These are the major things. And for each of these ones, whenever you find an item concerning, you must be able to specify which method of presentation are you going to be using. If I'm in statistics, then you must be very clear that it is a frequency distribution something. In case you are dealing with Venn diagrams, this is where we have sets. Then you need to be very clear that a Venn diagram of this and this. In case I'm doing with matrices, specify the method of presentation of your data, that I'm using the matrix of the to show this and this. In case it is probability and it is still diagram, then be specific of the method of presentation. But these are the major ones under the data and probability. Now, what are some of the scoring points when it comes to data and probability? Like Kangulumira, they have emphasized that a title is very, very key. Whenever you are dealing with this section, make sure that you do not forget a title. Those are the free scores that everyone must be able to get. You specify, is it a Venn diagram? Is it a tree diagram? Is it a matrix? What is it? Now, label your sets, because now use letters or names. Define what you are going to use unless the question has already defined. In case now, like the question we have been dealing with, in case you are dealing with this, make sure that you label, you clearly define that what am I using, that I'm using this to represent this, that this is for 40 tires, this is for this. Label. Insert the data correctly. Some of you have a habit of only drawing one set, that you come here, you draw your final set. Have the two sets. Have a set that has the unknown elements, where you have placed your unknown elements, and then after have another set that contains the actual values that you have obtained from your sets. And when you are making your calculations for the unknown values, ensure that you put small subtitles. Now that I'm calculating maybe for NT only, and clearly show that maybe this is 34 minus 7 minus xc plus xc plus 11 minus x. Clearly show how you are coming up with your things. So put those subtitles and let them be in a vertical form, one after the other, one after the other. In case you have reached somewhere, then you can say maybe vehicles that have all the 3 defects, and then show and then clearly define. So make sure that you have your calculations in a very good format. Let them be flowing clearly. Then on your conclusion, make sure that you make a good decision, but also you put a reason. Why are you basing on that? In your conclusion, let's have the digits that clearly show the kind of conclusion you are coming up with. What are you basing on? Now, for the item that we have been dealing with, we could make 2 conclusions. You could use probabilities to make your conclusion, or you could use digits, because you could conclude using the vehicles which had only 1 defect, because the vehicles that had only 1 defect were 67, and then the vehicle, half of the inspected vehicles, when you calculate 90 out of 2 is 47. So you could make your conclusion using 67 and 47, and then you say, since 67 is greater than 47, then the ministry should not make any establishment. However, someone could as well make a conclusion using probabilities. Now, when you are using probabilities, then always make sure that you compare using probabilities. Now, when you look at a half, let me remove, so in case you are using probabilities, then stick to probabilities. Now, like Kangurumida use the probability of 67 out of 94. That means that they are going to compare it with the half, meaning that you are going to compare 67 out of 94, which is approximately 0.7127, and then they are going to compare it to the half of the vehicles that are being inspected, which is 0.5. So that means that in your conclusion, you are going to compare 0.71 and the 0.5, and then you make your conclusion. But when you decide to bring in the probability, then you need to be very careful. Which words do we use? When we are dealing with probabilities, we have words we use. And what are some of those words? Now, under probability, we have what we call a probability scale. Now, the probability scale runs from 0 to 1. And here in between is where we have our 0.25 here in between. And then here we have our 0.75. Now, depending on what you are dealing with. Now, take an example for the item we have been dealing with. In case you get your answer as 0.5, that means that is an even chance. In case you get your answer that is below 0.5, then you need to know what words are you going to use. Are you going to use very unlikely? Are you going to use unlikely? Are you using likely? Very likely. So in your conclusion, when you meet probabilities and you have met a given, let me say a given answer. Let me say you have obtained your answer as, let me say 0.85, and this is your final answer. Then we expect you that when you are making your conclusion, you are going to say that it is very likely to this and this, because 0.85 lies between 0.75 and 1. So that means that the right word to use is going to be very likely to happen. In case you get your answer, let me say 0.1, then you know that 0.1 is between 0 and 0.25. So the best word to use is going to be, it is very unlikely to occur, or it is very unlikely to do this. That means that when you are dealing with probabilities, be very intentional on which words to use when you are making your conclusion. Not every word qualifies for a given what? For a given probability that you have been able to obtain. So you need to know the probability scale, know which words to use. Oh, even if they are fractions, you need to know that this is 0, this is going to be a quarter, this is going to be a half, this is going to be 3/4, and this is going to be 1. So depending on the fraction you have obtained, then you need to know that this is the best word to use under probability, this is the best word to use under this and the other. So that's what I wanted to clarify, that if you are dealing with probabilities, let your conclusions compare things in probabilities. That let the 67 out of 94 compare to the half, which is the 0.5. So you could compare 0.71 to this compared to the other. And when you are writing these probabilities, ensure that you write to at least 4 decimal places, such that your answer is very accurate. Avoid over rounding off when you are dealing with probabilities. At least make sure you have 4 decimal places for that given probability that you are dealing with. So allow me to end at that point. So that was briefly about that particular item. Okay. So allow me now to invite another school. I want to first be sure whether we are going to go to item number 5, but I want to ask whether Nakasonga, you are set. Nakasonga, are you set? Nakasonga, talk to us whether we are set.
Sir, we are not yet.
You are not yet set. Okay.
Yes.
Okay, Nakasonga is not yet set. So I'm going to call on another school, Kihi, to take us through item. Kihi, you are going to take us through item 10. Kihi, you are going to take us through item 10. I don't know whether Kihi High School, are we set? Okay, I'm failing to get Kihi High School. Okay, if Kihi is not yet, we are going to, yes, Kihi?
Not, we are not ready.
Okay, not
We
yet.
are not ready.
Okay. Okay, not yet, not yet. Then I'm going to invite Immaculate. I'm going to invite Immaculate. Send Immaculate. Okay. 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 Kihi, were you ready with number 5? Okay. Mary Assumpta. Mary Assumpta, kindly unmute. Mary Assumpta, kindly unmute. Mary Assumpta, kindly unmute. And you're going to take us through number 12. Mary Assumpta, if you are kindly unmute.
And the presenter who is supposed to take in has gone for breakfast because I've sent some shift of around 20 students for breakfast.
Okay. So which presenter is around for which item?
They are not here because I'm using room 2, which contains all the presenters, and I've just sent them.
Okay, it is okay. Palabek. Okay, Palabek. Palabek, are we set with, sorry, Palabek? Oh, I'm saying Palabek unmute for item 3. Oh. Okay. Fairmont, Christian. Okay, I don't, I'm failing to get some schools. I'm failing to get some schools.
Yo, sir,
Yes.
we are ready for item 6.
Okay, kindly let's start. Okay, that is Fairmont Christian Education Center, Tororo. Okay.
Okay, we are going to take us to item 6. And the item goes, a road construction engineer in Western Uganda is designing a sloping road section in a hilly area to improve transport and reduce accidents during the rainy season. The engineer proposes that the run of the road should be 20 meters more than the right. During planning, the engineer estimated that the side section formed by the right and the run of the road would be squared. Road safety guidelines recommend that if the percentage incline of a road section exceeds 30%, the road should be redesigned to reduce steepness. The engineer wants to help the supervision team determine whether the proposed road section is suitable for road users before construction begins. Okay, before I go further, this is Fairmont GM Christian Education Center, Tororo District, and our presentation is on item 6, which is patterns and algebra. Part A, we are going to come up with a triangle, and we are going to say let the right of the road be x. Let the right of the road be x. This implies run of the road equals x plus 20. Into brackets meters, which is equal to x plus 20 meters. That is it. Now we are going to come up with a triangle like that. And now we put the run, which is the run is supposed to be the base, and we are going to put there the base is x plus 20, as it was given in the scenario that the run is the 20 more than the rise, which means the base is x plus 20. And now the rise is the x. Now we are starting our calculation given area equals 150 meters squared. Given area is equal to 150 meters squared, area is equal to half base times height, which is equal to a half times x plus 20. That one's supposed to be in brackets. Now we are going to have that, which means we are going to come up with the x into brackets x plus 20, and we close, and the whole thing we divide by 2. And now we are going to come up, we are going to open brackets. We are going to open brackets. We are going to open brackets, and we are going to have x squared plus 20x, x squared plus 20x, divide by 2, the whole thing. This implies, which means from our scenario, we were told that the area of the what? Of the rise and the run, of the what? Of the thing formed by between the rise and the run should be 150, which means the area which is 150 equals, this implies 150 equals, this is last time, 150 equals x squared plus 20x divided by 2. Now, by cross multiplying LOHS with the RHS, by cross multiplying LOHS with the RHS, we are going to cross multiply the terms on the right hand side, the terms on the left hand side. So we are going to say 150 times 2. 150 times 2 is equal to 1. The one which is that 150 there is being divided by 1 there, which the one which we are not seeing but is there. 1 into bracket x squared plus 20x. 1 into bracket x squared plus 20x. $300, which means 150 times 200, we are going to get 300. 300 is equal to x squared plus 20x. Collect the terms to the left hand side. Okay, we are going to form a quadratic equation, which means x squared plus 20x is equal to 300. We are rearranging the equation. Now, we are going to obtain there a quadratic equation. We are going to form a quadratic equation. X squared x squared plus 20x minus 300. We are bringing the 300 this side to form a quadratic equation. Is equal to 0. And that is our quadratic equation. Now we are going to solve the quadratic equation using the quadratic formula. Using the quadratic formula to solve the equation. From the general equation, from the general equation, the general equation is ax squared, ax squared plus bx plus c equals to 0. Equal to 0. Then we are going to have comparing it with the x squared plus 20x minus 300 being equal to 0. Given, which means as being given this equation here, and we are going to compare it with the general equation of the general quadratic equation, which is like that, which means a equals 1. That is the coefficients. We're going to obtain the coefficients. A equals 1, b equals 20, c equals negative 300. That c is just a constant, negative 300. Now,
Excuse
given,
me. Excuse me.
Yes, please.
I'm going to ask, could we first close the door and then we see whether we can first close the door and we see such that we reduce on the light in the room. And then could we get someone to help us with the maybe holding? I don't know how we can, such that the screen is very clear. Maybe you could try, okay, at least a bit better. Okay. Okay. Could we try to adjust the position and then we see how we can have our body a bit more clear? Okay. There, the light is still too much.
Can we leave it there?
Okay. Oh. Okay, not yet, not yet. We can put it back in the first position, maybe. Okay, somewhere there, maybe.
Okay, thank you. We can continue. Given the formula, x equals, this is the general quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac.
Okay, let's have the camera move closer. Someone should hold the camera because Okay, do we have a blackboard in class?
We don't have a blackboard.
Okay, because okay, a bit better. Okay. Okay, we can continue at least from there. Oh, no, let the person not, now the light has increased again. There. There, getting better, getting better. No. Take back, take back. No, 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 no. It's now becoming too much. Okay, there, at least there. Maintain that. Maintain that. We can continue.
We are going to divide. We are going to divide with what we have got by 2a by 2a. So substituting for a, comma, b and c. We are going to have x equals negative, open brackets, 20. Plus or minus square root of 20 squared minus 4 times 1 times negative 300. Now that 4 and that should be in one bracket. Put them in bracket. Like that, yeah. Divide by 2 times 1. We're now going to have x equals negative 20 plus or minus the square root of 400 plus 1,200 divided by 2. We are going to have x is equal to negative 20 plus or minus the square root of 1600 divide the whole thing by 2, which means x equals negative 20 plus or minus 40, because 40 is the square root of 1,600 divided by 2. Now we are going to say either x is equal to negative 20 plus 40 divided by 2. X is equal to 20 divided by 2. X equals 10 meters. Or x is equal to, or x is equal to negative 20 minus 60, minus 40 divided by 2. X is equal to negative 60 divided by 2. X equals 30, negative 30. But x cannot be a negative for length. X cannot be a negative for length. Hence, X equals, hence we consider X equal 10. We consider X equals to 10. This implies base equals, which is the run, base into bracket run equals X plus 20, which is equal to, open brackets, 10 plus 20, the whole thing out of bracket, we are going to put there meters, which is equal to 30 meters. Rise equals X, which is the height into bracket rise, height into bracket rise equals X, and we know very well X is 10. Now they are telling us that determine the dimensions of the proposed road section, which means the dimensions are going to get base, right hand, and the hypotenuse. The hypotenuse is the one which is the slanting road, or the one, the incline. That one, the hypotenuse, is the one we are going to calculate now, because everything we have, we are going to draw a triangle, and down with the base is 30 meters, and the height is 10 meters. Now we are getting the hypotenuse. We are going to use using the Pythagoras theorem. Now we are going to say the base is the one going to be as our A, and the height is the one going to be as our B, and the other one is going to be as our C, the hypotenuse. That is A, that is B. So we are going to say S from A squared, from A squared plus B squared being equal to C squared. Now we are going to substituting for A and B. Substituting for A and B, we're going to have 30 squared plus 10 squared is equal to C squared, which means C squared is equal to 900 plus 100. C squared equals 1000. We are going to introduce square root on both sides. We are going to say root of C squared, square root of C squared is equal to square root of 1000. We are going to have C is equal to 31.6228 meters. That is our hypotenuse. Therefore, we are going now to conclude. We are going to conclude. Therefore, the dimensions of the proposed road are 30 meters run, 10 meter rise, and 31.6228 meter incline. That's now the road dimension. Part B, they asked us to find the incline. The item is saying, okay, the task saying, comment on the stability of the proposed road section for road users. But here, our condition was, road safety guidelines recommend that if the percentage incline of a road section exceeds 30%, which means you're going to get the percentage incline of the road section, but the percentage incline is going from 1. Percentage incline is we are going to get the what? We are going to get the gradient, and after getting the gradient, we are going to multiply it by 100%, and we get the percentage incline. So the gradient, we're going to calculate the gradient is equal to vertical rise over horizontal run vertical rise over horizontal run times 100%. Which is equal to 10. The vertical rise we have calculated is our height, and it is 10 divided by the horizontal run, which is 30 times 100%. And we are going to get 33.3333%. That is our percentage incline. Now we are going to comment on the what? On the stability of the road. We are going to say, therefore the road is not suitable. Therefore the road is not suitable for road users since the percentage incline exceeds 30%, and hence the road should be redesigned to reduce steepness. That's where our work has ended. Thank you so much for listening.
Okay, thank you so much, Christian Education Center Toro, for the presentation. And I will ask schools that let's always be patient. We are doing all what we can using the means we have, such that we can utilize the technology we have at hand. Now I'm seeing some hands up. I'm going to start with St. Ronald. St. Ronald.
Good morning, sir.
Yes, good morning.
My answer is my question is, when we are studying that topic, or when we are answering new curriculum way, we give planning, communication, and conclusion. So I think their presentation was not bad, but they didn't communicate to us. So they make a more clarification on that.
St. Ronald, let me hope you had, they have not written the conclusion, but the speaker communicated at the end, because the speaker, maybe you can repeat for him the conclusion you made. Okay. Yes, the speaker from Education Center, the last conclusion you made as your conclusion. Okay. Gomba.
Good morning, sir.
Yes, good morning.
Yes, for me, what I'm asking is that here in the question, there's a paragraph that said the engineer proposes that the run of the road should be 20 meters more than the rise. Then, according to what has been given there, we are seeing the run as we have seen the run. No, we have not been given the run there. Just we have been given the base. So we are not understand.
Okay. May I ask Toro come in? Oh, sorry. Fairmont, unmute. Unmute. Okay.
Okay, thank you so much for the opportunity once again. With the item, they told us that the run of the road should be 20 meters more than the rise. Now, we are saying that the run of the road, they're telling us that should be 20 meters more than the rise. But we are saying here, using the idea we were given, the run of the road is going to be in form of inclining surface, which means the run is going to be the base and the rise is going to be the height, according to our finding out or our review. Now, our conclusions were clear, and I think we communicated very well to everyone. And we said the first conclusion was about finding the dimensions, and we calculated our solutions, and we came up with the conclusion. Part A, we concluded that therefore the dimensions of the proposed road are 30 meters run, 10-meter rise, and 31.6228-meter incline. That's our conclusion that we came up with for part A. And part B, we concluded that therefore the road is not suitable for road users since the percentage incline exceeds 30%, and hence the road should be redesigned to reduce steepness, because they told us that the incline we calculated, and we were supposed to get the incline in form of the what? Of the gradient, whereby the gradient will get the steepness, that's the sloping surface. The gradient we calculated, and we got vertical rise over horizontal, which is 10 over 30, and the whole of it we multiplied by 100%, giving us 33.33%, and that is how we came up with our answer. Thank you so much.
Thank you for that. Let's have one more from Mother Kevin. Okay, fair to get from Mother Kevin. Yes. Now, dear students, I think allow me to Mother Kevin.
Thank you. Good morning.
Yes, good morning.
The only question I had was that when they were beginning the question, they actually were not clear on how they related all the dimensions they began with. And that brought problems when they were calculating the value of x. So we did not get clear information on how they got their values and how they related their dimensions.
Okay. Allow me to share my screen. Maybe I can throw some light. Now, thank you so much. Now, the section that we are dealing with is a section of patterns and algebra. And whenever we are dealing with this section of patterns and algebra, dear students, ensure that you define what you are going to use. Now, many times we have been used to things of telling you this and this. Now, the language being used here is testing your knowledge of gradient. You learned gradient in Senior 3, Term 1, and this is what the item is asking for. So you remember very well from your knowledge of gradient, and from what we have here is that we have this section of the load that they are constructing. Now, using the sketch that the school has used, they had a sketch of this nature. Now, the statement that says that they propose the run of the road should be 20 meters more than the rise. Now, you know very well that this is what we call the rise, and this is what we call the run. Now, meaning that when you are defining, you are going to say that let the rise, you can say let the rise be, let me say you have called it x. Meaning that where there is your rise is going to be your x. Now, where the run is, since they have told that it should be 20 meters more than, then here you're going to say that this is 20 plus the x. Now, that is the run. So, meaning that your run is going to be 20 plus x, and then your rise is going to be x. Now, the next thing you have to do, since they gave you that section of the road that covers, now this is the section here. That means you use your knowledge of areas. So you will say now that the area of the section is given by a half times the base times your height. And therefore they went on and said this is a half times their base, which was 20 plus x, and then times their height, which was x. But everything here was equal to the area of the section, which was 150. So now this is now the equation that you have formed that you are going to go on and solve. Now, whenever it comes to solving now for the value of the unknown, or now for this case, we have x. Now, when you look at this one, it forms a quadratic equation, meaning that now it is okay to use any method of your choice that is easy. You can decide to use the factorization. You can decide to use the bulldozer method. You can decide to use the completing squares, any method that is easy for you. But ensure that you show your working clearly. Let you define clearly all the steps. Make sure that you work from one step to another, one step to the other, until when you get to the other. Now, like we have said that always we must communicate. Since they ask for the dimensions, then we expect that under your conclusion, you are going to be able to tell us the dimensions of the proposed road section, like the school told us. Now, that is how we can define. But later on, like when they say comment on the suitability, like I've said that when you are making your decision, when you are responding back to the item, make sure you put there the basis. What are you basing on to say so? Like what shows, what proves that your comment that you are making is okay? Now, the comment, I was happy that the school went on to calculate the percentage incline. But here I will always propose that stick to the language being used in the scenario. In case the scenario is using rise and run, therefore, even when you are calculating your percentage incline, also maintain the language of rise out of the run, then times your 100, such that you have your 10 out of the 30 times 100, which was equal to 33.33%. So in your conclusion, when you are making the suitability, then go on and now compare the percentage incline for the proposed section with the recommended one, the 30%. Compare the two. Compare the 33.3 and then the 30%. But also go on and give the reason. Why would that one not be suitable? So if you listen very well, he went on and told us that because it will be very steep. Now here you are looking at interpretation of gradient. You looked at gradient and you know that when the gradient is very big, it means that something is very steep. So that means that you need now to bring your understanding from the knowledge you acquired when you are looking at interpretation of the gradient to making your comment, such that you give the reason why you are saying so and what could be the likely dangers if such recommendation is being made. So now that is what you had to do on that particular section. So in case you have other questions, kindly you can have them in the chat. Okay, I've seen maybe a question from St. Ronald.
For me, my question is about the way we have asked that we need to make the communication. And so the communication, for me, I expect that for example, finding, we use the word like a finding, calculating, or obtaining. I don't see in their responses. I don't know how they are presented.
Okay, now those are what you call when you look at like when you are communicating, what you are calling the communication. You could clearly just put what you are finding or what you are working on. When you look at how they are presented, you could have your sketch. So you could have a title that a sketch showing the proposed road section. Then after, go on and define that this and this. And then from there, go on. Communication is like you are responding back to what the item has asked for. So what we are talking about, those are mainly the subtitles you want to find. But it is okay now, like you can see now obtaining the area for the proposed section, but the area was already found. So you can say maybe obtaining the dimensions for the road section, something like that.
Yeah, okay, thank you, sir.
Okay, so, okay. Lastly, let's have Paul. Okay, I'll fail to get Paul. So
Excuse me.
I'm going to, yes, Paul?
For us, our teacher always tell us that we should define the unknowns for for obtaining those dimensions, and we put the titles, and we have correct substitution for the formula, that even if we don't put the formula, even if we don't put the formulas, but when we have correct substitution from the formula, that it is accepted, and the conclusions.
Okay. Now, one thing is that you must define that is okay. Anything under patterns and algebra, whenever you are dealing with expressions, you are dealing with equations, you define what you are using. And when you look at when we are starting, I told you that x represents the x is the rise. Let x be the rise. So that is the defining, the unknown that you are going to use. Then number 2 is that you must have your working clearly flowing. Have it clearly flowing, that I'm moving from this step to this, from this step to this. Then when it comes to having the formula, they do not give a mark for the formula. They don't give you a mark, or there is any score that is attached to the formula. However, I would encourage that always have your formula put there, because you may miss it out and you do not substitute correctly, because it is correct substitution that is always awarded. So have your formula there and then substitute correctly. Yes. So I would always encourage that you have your formula substitute. So because when they are awarding, even we look at correct values in the correct formula. So you must be able to use the correct values in the correct formula. So that is what is very important. Yes.
And he told us that, for example, when you have applied the quadratic formula, the bulldozer, that for example you can, like for example, that man had substituted those A, B, C. That like for example, if you state your quadratic formula and you substitute the what, those numbers correctly, that you can stop there and you use the calculator so that you can get the answers. And you say that either x is equal to negative 30 or x is equal to 10. Then you come and you conclude by applying the dimensions.
Okay, I would always encourage that show how you are coming up with the answer. Clearly show. You must have the steps on how you are coming. Use the calculator for just proving that what you have come up with is the correct thing. But clearly show how you are coming up with the answer. Okay, so thank you so much. Now I'm going to request that we are going to give you 10 minutes for a short break, and then we start from there. Now, when we come back, because I know students have been sitting for a long time, so kindly have a short break of 10 minutes, and then at exactly 11:42, we are going to start the session. We are going to start the session. Okay. So have a short break, and I'm requesting that let's not okay, so we are having a short break just for 10 minutes, and then at 11:40 we are going to start. I'm going to first pause the recording, and I will ask people not to play with the screen. So kindly do not play with the screen. Don't share anything as we wait for the students to have a break. And so have a break, and then we are going to start again. So you're having a break, have a short break, and then St. Mary's Assumpta, kindly prepare. You're going to be the first to present when we get back in 10 minutes. So at exactly 11:40, we shall be starting again. So I request schools, you can have some photos from for the students that are attending. So I'm going to be sharing here the items on the screen, such that those who are still around, you can be reading through. Yeah, you can be reading through because these are the items we are going to be doing. Alpha, at your level, there is in senior 3, term 3, you learn about quadratics, and the quadratic formula is there on your syllabus. So no penalty if you use it. It is there on the syllabus. Okay, Kihi High School, kindly prepare for item 10. Okay.
Hello, hello.
Yes. Staff, I'm seeing your hand up. Okay, the break is done and we are now back. So I'm going to ask kindly do not share your screen. Do not share your screen. Do not share your screen. Okay, but I think okay. So may I ask now that we have the first school, we are going to start from Kihi High School. Are we set? Kihi?
Yes.
Okay. So kindly. Kihi, let's have the boards clearly seen, the flip chart. Oh. Okay. Okay, we can start.
Okay, hey everyone, this is Brinju Reset from Kihi High School, and I'm presenting to you item 10, and it is all about data, but probably matrix. So according to our scenario that we have, it is reading that Kachira Sugar Limited supplies premier sugar to supermarkets across Uganda. The sugar is packed in bowls containing small household pockets and in bags intended for bulky purchase. Then they are telling us that at the beginning of June, Kachira Sugar Limited supplied Mega Supermarket with 25 barrels and 10 bags of sugar. During the same period, Quality Supermarket received 30 bowls and 6 bags, while Capital Shopper Supermarket received 15 bowls and 12 bags. Then Kachira Sugar Limited charged a wholesale price of 80,000 shillings per bale and 220,000 shillings per bag. Then they are telling us that at the end of each month, Mega Supermarket reported selling 22 bells, and 8 bags of sugar. Quality supermarkets reported selling 28 balls of sugar. Then they attend us that in addition, 2 bags were damaged during the storage and could not be sold. Then they attend us that Capital Shopper supermarket reported selling 14 bells and 11 bags of sugar. Then the supermarket sold sugar to customers at a 95,000 shillings per ball and 250,000 shillings per bag. Then before deciding on the distribution of the sugar for the following month, the finance manager requested a monthly review report showing the value of sugar supplied to each supermarket, the revenue generated from the sales, and the stock remaining at the end of the month. Then the report would be used to determine which supermarket should receive additional stock in the following month. Then we have that's the one is saying that help Kachira Sugar Limited to organize the supply, sales, and pricing information in laws and columns, clearly stating the order of the data that will be used. So as I had earlier told you, our discussion or our item is all about matrix, and in our scenario, we are saying that Kachira Sugar Factory, Kachira Sugar Limited supplied sugar to different supermarkets. We have the first supermarket as Mega Supermarket. Then we have the second as Quality Supermarket. We also have
Your
the next
screen
one
is
as
not clear. Kihi, your screen is not clear.
okay.
There
But
is
you
a
try
lot of
to listen very well. I think I'm audible. Okay, you will bear
not
with us,
yet
but
clear.
then let me try to be
Like
more audible.
Kihi, we cannot see. We cannot see. So we need to get a better position. Like the screen is not clear. The screen is not clear. I don't know whether you have a board, maybe.
The board.
Yeah, because
Okay. So we are discussing about matrix.
okay. Okay, before you continue, we need to first make the board clear, such that members can follow, because we cannot see what you are writing. Okay, so Key,
Yes.
yes, not yet. Okay, so Key, we are going to first give you time and then first see how we can sort out the board issue, because your board is not clear and we can't read what you are writing.
Okay, thank you.
First sort out the board and then you come back. We are going to give you an opportunity.
Okay.
We can only see the words are not clear. Maybe you can get a blackboard or a board where you can fix the camera and then we can be able to follow up from there. It can be very much clear. Okay. So St. Mary's Assumpta, could you first come in as he gets a bit sorts out the board? Members, we shall go back to Kihi as they sort out the board issue. But let's first go to St. Mary's Assumpta. St. Mary's Assumpta, which board are you using? Kindly unmute. Mary Assumpta? Mary Assumpta?
Yes.
Okay. Okay. So I think we are failing to get Mary Assumpta as well. Gombe High School. Gombe. Gombe, could you unmute? Because
Okay, Mr. Kaziba, we are good now.
okay. Okay. We can start.
Okay, good morning. My name is Adrafa Brianna Juan from St. Mary Assumpta Girls Secondary School. I'm going to take you through item 5, which reads, during the third term holiday, a parent concerned about the increasing amount of time his child was spending on a mobile phone at home. In order to monitor the child's behavior, the parent recorded the total number of hours spent on the phone each week during the holidays. The child spent a total of 5 hours on the phone during the first week, 6.5 hours during the second week, and 8 hours during the third week. The child continued increasing the time spent on the phone following the same pattern. The parent also read from the internet that spending more than 15 hours on a mobile phone in a week may be excess for a child. The parent wants to predict the child's future phone usage and determine whether the phone may need to be withdrawn. So let us go to the task, that is part A, which reads, determine the relationship between the week number and the number of hours the child spent on the phone. So from this scenario, we have two subjects, that is the work in then time in hours. Therefore, we are going to define those subjects whereby we shall say, let X represent work and then Y represent time in hours. But in the scenario, they say that the child continue increasing the time spent on the phone following the same pattern. So here we are going to follow the same pattern, whereby to get the others, when you subtract, you will get, when you subtract 6.5 minus 5, it will give for you 1.5. So we are going to use that relationship whereby to get others, the time, that is why we shall add 1.5 to get the various one. But the task is not asking to get that. So here we're going to get relationship, but we are going to base ourselves on linear equation, whereby that is equation of a straight line, whereby we need to get the gradient. So gradient equals to change in y over change in x. We are going to take two points as a coordinate. So from there, we are going to take the points from the hours. So we are going to take 5 and 6.5. And also, so yeah, we are going to take that one. So we are going to say gradient, which is n equals to change in y, whereby change in y is y2 minus y1, and then out of x2 minus x1, which will be equals to our y2 is 6.5 minus 5, and then x2 is 2 minus 1, which will give us 1.5. That is the gradient. So to the next, we are going to use the equation of a line which states y equals to mx plus c. That y is a coordinate, it's a point for y, and then m is a gradient, and then the c is a constant. So using 0.15, which is taken from the week 1, the first week, and then the hours spent in the first week. So we shall replace, we shall substitute the given point into the equation, which states y, which is 5, will be equals to the gradient, which is 1.5, times x, which is 1 the week, then plus constant, whereby when we substitute, our constant will be 3.5. Thus, so we need to give our relationship whereby all the constant in this equation we have got all the constant in the equation, which is 1.5, and the other constant is 3.5. Therefore, our relationship will be y equals to 1.5x plus 3.5. That is for the A part. Okay, but not only that, after getting the relationship, you substitute for other values, whereby you get, that's why we got all those values from substituting, because we have substituted for other values using the relationship. So y, you put the value y, the hours will be equals to 1.5 times the week, which is x, and then plus 3.5. That's when we got other values. That determine the relationship. So the B part reads represent the relationship between the week number and the number of hours spent on the phone for the past 7 weeks on a suitable graph, and comment on the child's phone usage during the holiday. So for this, since we have got the work and the hours for the first 7 weeks, we are going to plot these values, the values on a graph, whereby, but the suitable graph here will be a scatter graph. So you are going to plot these values. Thank you very much. Good afternoon. Now I'm going to take you through part C of the question, which says calculate the weeks during which the parent may need to withdraw the phone from the child. And then from the scenario, it said that the child continued increasing the time spent on the phone following the same pattern. The parent also read from the internet that spending more than 15 hours on a mobile phone in a week may be excessive for a child. And then in the 7th week, we find out that the time spent by the child on the phone has not exceeded 15 hours. So we are going to the 8th week, whereby we shall use the equation of the line, which says x is equal to 1.5 x plus 3.5. So we are going to substitute. We shall say y, which is not, with the value which was not given, equals to 1.5, the gradient, times 8, which is the what? The number of weeks, plus 3.5, the constant, whereby we shall multiply 1.5 times 8 plus 3.5, and we shall be getting 15.5. And for that reason, since 15.5 is the number of hours which will be spent by the child in the 15 weeks, we shall conclude by saying that the parent needs to withdraw the fund from the child in the 8 weeks, since the time spent by the child on mobile phone in the 8 weeks is going to be more than 15 hours. Thank you. Any question?
Could you kindly show us the graph if you have it?
No, we don't have the graph.
Okay, we don't have the graph. Okay, we can first pick some questions. I'm saying yes, Jacob and Beatrice.
Yes.
Jacob and Beatrice, you can ask.
Here, Beatrice Secondary School, Chankwanz. Yes, I'm from Beatrice Secondary School, Chankwanz.
Yes.
I'm asking for Assumpta Gallows. They have said that the parent may need to withdraw the phone during the week 8, but we haven't seen the numbers from the week 1 and week 2 and week 3. So it was better, could be better when they show us their graph, because even the title of the graph, they have not told us the title of the graph. So I'm kindly requesting to know the number in week 1 and week 2 and week 3, and even the title of the graph. Thank you.
Okay, thank you. Here I have the graph, and the title of the graph is a line graph representing week and week number and the number of hours spent by a child on the phone usage. This is the graph. In week 1, let me say, according to the scenario, in the first week, the child spent 5 hours on the phone usage, and then in the second week, the child spent 6.5 hours on phone usage, and then she continued using the same gradient. Let me say here, the same pattern, which is 1.5. So in the third week, she used 8 hours on the phone usage. Okay, I'm going to request you to say the whatever that the relationship in the graph.
Okay, we are going to share the graph in the chat.
Okay. Let's have another question from Ntenunji SS. Ntenunji.
At Intenunji, we would like to know how you got the values that cause. We are not knowing how you got these values very well, of course, and even we want to see very well how they got this gradient, and we need to understand where they come from. And even we would like to know to see on that graph, because we are totally not understanding item 5. Thank you.
Okay, for the gradient, we got the gradient, which says the gradient is equal to tangent y over tangent x. And then for the values of y, we chose the values. Let me say the time taken in hours in the first week and in the second week. And then we use the number of hours spent in the second week to represent y2. And then the number of hours spent in the first week to represent y1 over the value of week 2, which is 2, minus week 1, which is 1, represented by 1. Then from there, when we subtract 6.5 minus 5 over 1 over 2 minus 1, you get 1.5 over 1. And when you divide 1.5 by 1, you get 1. That was how the gradient was got. And then the formula which we use there is y is equal to mx plus c. Y will be for the value of let me say for the hours spent in a week, which is equal to m, the gradient times x, the value of x plus the constant. The constant we got it by substituting the coordinates, the coordinates of x and y, whereby y is equal to 5. Y is 5 is equal to 1.5, which is the gradient, times 1, the value of x, plus c, which was not given the constant. And then when you multiply 1.5 times 1, you get 1.5. And then when you subtract 5 minus 1.5, you get 3.5. And for that case, 3.5 is our constant. And then you use that formula for getting those other values of the hours in a week.
Okay. Thank you so much for the presentation. Kindly, we are going to wait for the graph in the chat such that people can be able to see the kind of graph that we do have. Now, dear students, when you look at the item that St. Mary's Assumpta they have been doing, it is under the element of construct of number patterns. That's where it lies. Now, when you look at that item, there are 3 things that can come out clearly very well. That one, when you look at patterns and algebra, that specific question had different concepts that you could apply for you to be able to do it. They gave you a given pattern, meaning that item, someone could use the knowledge of sequencing and patterns. In senior 1, you learn about sequence and patterns, and you learn about how you generate a general rule for a given sequence that you may be having. So mean that when you are attempting this, someone can say that in the first week, the person spent 5 hours. In the second week, someone spent 6.5. In the third week, the person had spent 8. Now, when you look at it very well, you are noticing that there is some kind of pattern from 5 to 6.5, 6.5 to 8, and the rest of that. Now, that means that you could use your knowledge of sequence and patterns to do it. However, someone could as well apply the knowledge of equations in there such that you know what the constant is, which was 1.5, and then you build up from there to come up with a general rule. But also, when you look at that same item, it had a concept. It had a concept of inequalities somewhere that you had to apply. So that means that the topics that were being captured, it had a concept of equation of a straight line somewhere. It had inequalities somewhere. You could apply the knowledge of sequence and pattern somewhere such that you come up with a solution. But I'm going to first focus on the third part that required you, when you look at the third part, it asks you part C, calculate the weeks during which the parent may need to withdraw the fund. Here they ask you that they want the algebraic calculation. They want you to show the calculation. Now, when you look at the relationship that we had developed, you notice that the relationship that Mary Assumpta came up with was 1.5x plus maybe 3.5. That was the relationship that they came up with. Now, when you look at item 3, they want you to calculate the weeks. What does it mean? It means that when it comes to calculation, you need to be very, very careful. What are you going to do? Now, from the item, from the scenario, they told that the parent from the scenario, you could notice that they told that the parent also read from the internet that spending more than 15 hours. Now, more than 15 hours, members, can you put in the chat clearly what inequality calls in for that? If they say more than, which inequality do you think you would have used? You looked at inequalities and regions when you were solving. So which inequality are we going to use? Type in the chat quickly. Those who are in position. Greater than. Very good. So now when you are attempting the third part, we would expect you that you are going to come up with now an equation with 1.5x plus the 3.5 greater than the 15. Now here you don't use equal sign because they told you to calculate. They want you to solve. So we do not expect, because the scenario told you that more than 15 hours. So we expect you to handle like this. Because when you are looking at inequalities and equations, you looked at how to solve inequalities. So that is the knowledge you needed to apply. Now for such, now we shall expect that now you are going to come and tell us that now what are you going to do? You are going to solve this kind of equation. You will say that 1.5x then plus 3.5 minus 3.5 is greater than 15 minus 3.5. Oh, sorry. I think we are here. So then you'll come and say that now 1.5x is greater than, this is 11.5. Then after, you divide through by 1.5, divide through by 1.5. And therefore, you'll get your x is greater than 7. That is 6667. Now, when you reach here, your value of x is greater than 7.66. And now, when you look at the question, they want to calculate the weeks during which, meaning that now the parent, since the value here is greater than 7.x, then you can approximate that now the parent should withdraw the phone from the child during week 8. So now that's how you deal with that. So here, when you are calculating members, always read what does the scenario. Next time, even you may find sometime when we are testing, what about, do you know how to divide inequalities? Imagine you had a negative. Maybe you had remained with negative 2x greater than maybe 14. Here we shall be testing. Do you know that the inequality changes the moment you divide by negative? So that's what will come now next time. So that means you need to know that with the moment you divide by negative, the sign has to change. So now you need to be very careful with the wording such that you don't just assume that it is 8, but how are you getting the 8? Are you following the right mathematics when you are calculating? Then when it comes to the comment, because there they ask you that comment on the child's phone usage during the holiday. Now, when you draw the graph on the graphical work, I want to emphasize that whenever you are dealing with the graph, make sure that, let me see whether I can get one graph here. Let me assume that this is the graph where you have drawn that I have come. Let me just use this, that this is my graph that I've come up with. This is my graph, something like this. So we say that a good graph must have a title, like a heading. Give it a heading, that what is your graph representing. Now, when you are dealing with graphical work, make sure, always ensure that you label your graph. always ensure that your graph is well labeled. What is it that you are doing? You label it very well that this is my y-axis and this is my x-axis. That is the labeling we are talking about. Make sure that you have a title about what your graph is all about. Now, after labeling, make sure that you name your graph. Labeling and naming are different. Now, when we are naming, now like for this particular graph that we are dealing with, you are going to ask yourself, what are you going to put along the y-axis? Basing on the scenario, and what am I going to put along the along this? Then I will know that along here, I'm going to put hours. The hours spent on the phone. Spent on the phone. Then what am I going to put here? I'm going to put here the week number. That in this week, this is what happens. Then after, you are going to go on and draw and like you do your plotting, you plot your points, and then you can go on and then draw your line. Then in case you have come up with a line, feel free to label it. Label your line that this line is maybe 1.5x plus 3.5. And do not forget to demarcate. Demarcate and let your scale be consistent. Demarcate very well. Have the demarcations and have starting points. That if along this axis you are starting with 0, let it be clearly seen. If along this axis you are starting with 0, let it be clearly seen. And where possible, if you can, you could as well put a scale to show us what does the horizontal scale represent and what does the vertical scale represent. But do not forget, always label and name. Where units apply, then go on and apply the units. In case there are hours, you put them there. In case there are days, you put them there, such that now your graph is well complete. So that is very key when you are dealing with this kind of construct. So allow me. Okay, I'm just going through the chat in case there is something that we have not been able to address. Oh, now they're asking the kind of relationship. Now, when you look at this kind of graph, you are not seeing that as the week numbers are increasing, what is happening this side? The hours spent on the phones are also increasing. As the week numbers are increasing, the number of hours the child is spending on the phone is increasing. Now, that means that in your comment, you can say that the child's phone usage is increasing steadily by maybe 1.5 hours every week. Yes, now this is the naming. The labeling is just putting y-axis and x-axis. The naming, you put the variables being used, that these are hours spent on the phone and these are the week numbers. Yeah. Okay. Okay. Oh, okay. So Mary Assumpta has shared the graph in the chat that you can use. Okay, thank you so much, Mary Assumpta, for the presentation. But members, do not always forget to clearly define the variables when you are dealing with this element of what? Of construct. Mpoma Royal College, I don't know whether it is a question. Mpoma? Okay. I want to ask whether Gombe, you are set now. Gombe, are we set?
Yes. Yes, sir.
Okay. Over to you, Gombe. Oh, now, please take note. Allow me to address this. Take note that in the syllabus, we do not have partial variations. Partial variations is not on the syllabus. So what we have only direct and indirect proportions or inverse, but there is nothing like partial variations. So do not expect any item that is testing for partial variation. But partial variations can partly be applied when you are using the equation of a line. But here, we do not test for partial variations at O level, and it's not on the syllabus. The syllabus clearly defines only direct and indirect. So all items will be about direct or indirect. Even here in your conclusion, when you look at that graph represents a direct relationship. Okay, over to you, Gombe.
Good afternoon. So we are going to be discussing item 7. We're going to begin by reading the question. The question says that a family is planning a grand graduation party and approached a hotel for a venue and catering services. The hotel of management offered them a choice between hosting packages. Package Alpha required a fixed venue booking fee of 600,000 shillings together with an additional charge of 18,000 shillings per guest. So we've noted from the question that the package Alpha needed a booking of 600 shillings, an additional fee of 18,000 per guest for food and refreshments, and a discount was given, 10% discount was given on refreshments when the guests exceed 80. Yeah. And the total expenditure is 2,220,000. So we first get the money, the total money minus the booking fee, and we get 1,620,000. After that, we get the amount that each guest is supposed to be paid for, and we divide it by the amount so that we get the number of guests, which is 90. And since the guests exceed 80, we are given a discount. So we calculate the discount that we are given, which is 162,000 shillings. And we separate it from the total amount to get what money we are supposed to pay, which is this, if you can see that screen, which is this here. And then you continue. Yeah, we continue to the next slide. Yeah, so the total money for the Alpha package. So you get how much money the Alpha package will be needed, and this is the amount. Then we go to the Beta package. And okay, the Beta package, they say there is no amount required for booking, but the hotel charged a flat rate of 22,000 shillings per guest. The package also required a minimum attendance of 40 guests. This means that they needed more than 40 guests. So you get the amount that is needed, divided by the amount each guest is supposed to pay for food and drinks. So that we get the number of guests, which is 101 guests. So that means that they should opt for the Beta package because it will allow them to have a maximized attendance of 101 guests. Yes, thank you. I would like to pass on to my colleague to explain part B.
So, as I'm continuing the question, it says, the organizing committee consisted of 15 members and planned not to exceed a total expenditure of 2,220,000 shillings. The committee members agreed to contribute equal amounts of money towards the planned budget. However, before making their contributions, 3 members withdrew from the committee, forcing the remaining members to adjust their contributions so as to meet their original budget target. And part B says, determine the effect of the withdrawal of the committee members on the contribution of each, determine the effect of the withdrawal of the committee members on the contribution of each remaining member. So they were asking us to look for the money that the remaining members needed to pay after the withdrawal of the 3 members. So before, all the 15 members altogether had to pay 148,000. But to find the difference, we have to look for the money paid after the withdrawal of the 3 members. So we subtract 15 minus 3 to get 12 members that remained, and we divide it by the 2,220,000. After dividing, we get the amount 185,000 Ugandan shillings. So meaning we subtract the fee that the 15 members had to pay minus the from the fee that the remaining members are paying, leaving us with 37,000 shillings, meaning the withdrawal of the committee members on the contribution made by each member, they had to pay an additional fee of 37,000 shillings. Thank you.
Good afternoon. I'm going to be taking you through part C of the question, which says, determine the original number of laborers in the hotel's regular cleaning crew before the additional laborers were deployed. So in the question, they're telling us that immediately after the graduation party, the hotel venue had to be thoroughly cleaned before another function could take place. The hotel's regular cleaning crew could complete the cleaning work in 24 hours. To ensure that the venue was ready within 16 hours, the hotel manager deployed 8 additional laborers of the same capability. So in this part, we are going to look at indirect proportionality. But before that, we have to first describe our terms. And since we don't know the original number of the cleaning crew, we have to first let the original number of the cleaning crew be Y. So we let the original number of the laborers be represented by Y. And then after that, we have to we have to define the terms. And in this case, we have the laborers and the hours. So we let the number of laborers, number of hours, and the constant of proportionality be represented by L, H, and K. Meaning that the laborers will be represented by L, the number of hours will be represented by H, then the constant of proportionality by K. So in this case, the L is indirectly proportional to the H, meaning that when the number of laborers increase, the hours reduce. So after knowing that, the first place we know that the hotel's regular cleaning crew could complete the cleaning work in 24 hours, whereby we don't know the number of workers, but we know the time those workers are going to take. So we are going to use this to find the constant. So the Y is equal to K out of 24. The K is the constant. The Y represents the original number of laborers. Then the 24 is the time taken by the laborers to finish cleaning. So then we find the K by multiplying the 24 on both sides. So here we cancel out the 24, since the 24 goes with this, then multiply Y times 24, giving us 24Y is equal to K, meaning that the constant is 24Y. The second statement said that to ensure that the venue was ready within 16 hours, the hotel manager deployed 8 additional laborers of the same capability, meaning that as they added 8 more workers on the original cleaning crew, the hours reduced to 16 hours. So we are going to use this equation to solve for K. No, to solve for Y, sorry. So still we say the L is indirectly proportional to the K out of H. We already know K is equal to 24 out of Y, 24Y, sorry. Then the L is Y plus 8. Then the hours are 16 hours. So we substitute for each. Then after that, 24Y out of 16. No? So in this case, we have the L, the number of laborers, and here we have Y plus 8, equaling to 24Y out of 16. 24Y is our constant. Then the 16 hours is the time taken for the Y plus 8 laborers to finish cleaning. So you multiply the 16 on both sides still, because we need to find the Y in this case. So when you multiply 16 on the 24Y out of 16, the 16 goes by the goes with the 16. Then this side we are going to remain with 16 into brackets Y plus 8. So to remove the brackets, we have to multiply the 16 by all the values in the brackets. So multiply the 16 by Y and the 16 by 8. 16 times Y will give us 16Y, then 16 times 8 will give us 128, equaling to 24Y. So we have to get the 16Y to this side where the 24Y is, so as we find the Y. So we shall remain with 128 this side, then 24Y minus 16Y on the other side. So we have 128Y is equal to 8Y, because 24 minus 16, you get 8Y. And then we divide by 8 to get the value of Y. And in this case, we are going to get 16. Our Y will be 16. And since in the first place we said that let the original number of laborers be represented by Y, our answer will be 16. So you conclude by saying that the original number of laborers was 16 in the hotel's regular cleaning crew before there were additional laborers. Thank you.
Thank you so much, Gombe High School. We have some questions coming in. So we are going to first respond to those items. Okay, we are starting with Alpha. Unmute. Masinya SS, you can as well unmute. Beatrice Secondary School, unmute.
Hello.
Okay. Beatrice, unmute. Okay. I'm failing. Okay. Bishop
Yes,
Chester.
it's Beatrice Secondary
Okay,
School. I'm
Beatrice,
a
go
listener.
on.
Yes, sir. Yes, it's Muguru. It's Muguru is not Beatrice Secondary School. It's a very my pleasure to be with Gomba High School. I have liked their response. However, my question is what about the conclusion on part A and part B? Because I have not seen the conclusion. How can I conclude on part A and part B? Thank you.
Over to you, Gombe.
So for part A, the conclusion is the question was asking for part A. The question was asking for the question was asking for a suitable package for the grand graduation party if they intend to maximize attendance while remaining with their planned budget. So, to conclude, we're supposed to say the committee should use the alpha beta because the package beta because it allows them to have a maximized attendance of 101 guests, unlike the alpha package that allows them to only have just 90 guests. Then for part B were asked to determine to determine the effect of the withdrawal of the committee members on the contribution of remaining member. So for part B, you had to conclude by saying the withdrawal of the committee members on the contribution of each remaining members, it led to the remaining members. No, sorry, that's from English. Let me phrase it better. The withdrawal of the committee members led to the payment of an additional fee of 37,000 for the remaining members. Yes, thank you.
Cool. Okay. My failing. The Uganda Martyrs centenary. Okay. Mpoma, you have a question? Mpoma, unmute. Mpoma girls.
Yeah. Yeah.
Hello.
Yes,
This is
Mpoma.
Mpoma Girls. It's Mpoma Girls, not Royal. And then
Okay.
for me, I want to inform those guys who are discussing.
Yeah,
But for us, we
no.
have not understood the question. From the start, as if they were just reading. It's not like we read the question for a long time. We are just trying to follow. So I'm kindly requesting that they may reread and make us understand so that they may explain what we are understanding. Thank you.
Okay. Gombe, could you summarize for them such that they can be able to get something from their presentation?
Okay, let's go through the question step by step. The question says, let's start from part A. The question says, a family is planning a grand party and approached a local hotel for venue and catering services. The hotel management offered them a choice between two hosting packages. The first package is package Alpha, which required a fixed venue, booking fee of 600,000 shillings, together with an additional charge of 18,000 shillings per guest for food and refreshment. However, to encourage larger gatherings, the hotel offered a 10% discount on the total food refreshments bill, and whenever the number of guests exceeded 80. So, here, I tried to summarize the question. Package Alpha requires a booking fee of 600,000, and it requires an additional charge of 18,000 shillings per guest for food and refreshments. It also offers a 10% discount on food and refreshments when the guests exceed 80. There was misspelling here, but yeah. It offers 10% discount when the guests exceed 80. And the total expenditure is 2,420,000. So we first find the money that they remain with after paying the booking fee of 600. We get this by subtracting the total expenditure minus the booking fee, and we get 1,620,000 shillings. So we proceed and we find the number of guests who will attend if at all we are to use the Alpha package. And we find that when we divide the amount that's supposed to be paid by each guest, we get 90 guests. Since the guests exceed 80, which means we are going to be able to get that discount because our guests are 90, which exceeds 80. So we calculate the discount that we are going to get by getting 10% of the money we pay, and we get a discount of 162,000 shillings. So minus the amount you're supposed to pay, we get the money we pay after getting the discount, which is 1,458,000. So after that, we find the total money for the alpha package, and it's shillings 2,058,000. I guess you understand that part. So we go to the package beta. Let's go back to the question. So they say package beta required no venue booking, but the hotel charged a flat rate of 22,000 shillings per guest for food and refreshments. The package also required a minimum attendance of 40 guests. I summarize the key points in the question. So they say that shillings 22,000 is paid by each guest, and a minimum of 40 guests is required, which means I need 40 guests and above, greater than or equal to 40, because we all studied inequality. So we know that what that means. If they say minimum of 40 guests, they mean greater than or equal to 40. So here, we get the money that was required for the event, divide by how much each person pays for food and refreshments. And we're able to get 109.909 that we rounded off to get 101 guests. And that is how we're able to find out that the beta package allows us to have a maximum attendance of 101, unlike the alpha one that only allows us to have 90 guests. Hence the conclusion that the committee should use the package beta, where they will have 101 guests, unlike the alpha, where they will have only 90 guests. This shows that we understood the question. Yes, thank you.
Okay. Thank you so much for the presentation, Gombe. I'm going to throw some light on that question a bit. Okay, allow me to share my screen. Now, that question had two approaches that someone could use. The approach that Gombe used is very okay. You could as well go into that approach. You could use that approach and then you get the answer. Another person could opt for another option. And the second option, because when you look at the scenario, what was the problem within the scenario? Always, whenever you meet these scenarios, always read the question, go through it. After going through it, you could underline what is the mathematics. That you come here, underline the mathematics in the question, that some of the mathematics I have to write from words to figures. There is discount. Highlight all the mathematics you have. So someone could have approached it using the approach that Gombe has used. Another one could as well say that, no, I could approach it from another perspective of knowing how many guests can I invite if I use the alpha package. How many guests can I get when I involve in the beta package? Someone could use that kind of approach. Now, in case you decide to use that one, then it means that for you, you are going to be basing on the number of guests you could be able to obtain when you are using the alpha package. Meaning that you could have your work well organized and say, using the package for, let me say, I say package alpha. Then under package alpha, you need now to first define, like we have said, that you need to define how the different variables you are going to use. So you can say that let my n equal to the number of guests. The number of guests. So here you are defining what you are going to use. From there, you are going to summarize that now I am looking at the booking fee. Now, mind you, whatever thing you summarize from the question is going to be attracting a score, given that it is there. So take an example, 600,000, write it there. That now the booking fee is shillings 600,000. Now this one will attract a score, together with an additional charge of 18,000. So also summarize it here. for food and refreshment. So you summarize that additional fee for food and refreshment, then also write it there, which is per guest. Now, what do you need to identify? That if you are to calculate the number of people, here you need to be very mindful of the language used in the item, because they told that the number of guests exceeded, because they told that, however, the total, however, to encourage larger gather, they offered a discount of this on this doing this. Now, you need to ask yourself, what could be the total cost for if I'm to use the alpha package? Oh, if I'm to use the alpha package, what is the total cost? Mind you, when you read through the question, you need to understand that how much money was available that these people were planning for. When you look here, you could note that they planned not to exceed a total of 2,220,000 shillings. This was the plan. Meaning that if you are making any calculation, that amount should not be exceeded. So someone could use that approach to know how many guests can be invited using the package for alpha. By looking at the cost, so someone could say that now the cost, which is the booking fee, is going to be 600,000, then plus the number of guests invited, but each guest is contribute this, and then you say now, since they have told not to exceed, then you will say that now this one is going to be less than or equal to that 222,000. And then after you make such that you know how many guests can you be able to invite using this kind of approach. So you could go through that kind of thing. Now, if another one, so here you'll find that the maximum could be 100. Then another one could go on and say, what about when I use the package for beta? Also, you find out how many people can you be able to invite if you are to use the package for beta. Then you get your calculation. So for that one, you'll get that 100.909. And since now here they told that you should not exceed, you'll find that also the maximum you can invite is 100. But when you look at the cost per package, depending on the people you're going to invite, you'll find out that the beta, for the beta, you'll have around 2,200,000. Then for the alpha, you'll have around 2,220,000. Then you make a conclusion basing on that. So that is the second approach someone could have used by looking out how many guests you could invite using the other package and how many guests you could invite using the beta package, such that you make your conclusion basing on that. So that could be the second approach someone could have used. Then, since this is under number patterns and algebra, like when you look at this paragraph here, now here they are inviting you to apply your knowledge of proportions. Like I said at the start, that under algebra and patterns, we are mainly looking for proportions. So here we are looking for mainly direct and indirect proportion, or what you call the inverse proportion. So whenever you read the item, you need to know when it comes to direct proportion here, you need to look out for two things. You have to reason that as one item is increasing, the other item should also be increasing. If this item is reducing, this item should also be reducing. That's what we call the direct proportion. When it comes to inverse proportion, one item increases, another item decreases. One is going up, the other one is going down. Take an example. In case it is distance, and maybe I'm looking at distance and speed. What happens that the more speed you drive at, the more distance you'll be able to cover. But when I look at speed and the time, so more speed, more distance to cover. So now that is what we call the direct proportion. However, if I'm looking at the speed and the time, the more speed you drive at, the less time you are going to take to be able to complete that particular journey. Now, this is what we call the inverse proportion. So always read the question that if I increase the number of workers in my hotel, what will happen to the kind of work? That the more workers you are going to have within the environment, it means that the less time will be taken to complete a given piece of work, given that all other conditions are kept constant. So always make sure that you look out for that. That what are they looking for? Item 2, we mainly test for proportions, direct and indirect. And please let's not go into something beyond the 2 proportions that are specified within the syllabus. Okay, thank you so much once again for the great presentation, Gombe High School. Light vocation, is it a question? Okay. Teacher Lawrence?
Good afternoon, everyone on call. Mr. Kaziba, I have something I want to clarify as well. It is not far away from the opinion you've given about proportions. However, it's just a combination of both direct and indirect sometimes. It's not just that someone may be off the scope. However, it is possible to connect the item that item 5, the solution the candidates were handling by the help of an idea and partial variations. But just looking at them as a combination of direct and indirect, because a candidate could do shortcut. I don't know whether my screen is visible, Mr. Stefan.
It is very visible, Charlie.
All right. A candidate was working with a combination of values that I could arrange as XY, where we had 2 against 6.5. Then we had 1 against 5. A candidate could use them with a linear relationship, y equal to a plus kx. Even if I don't go into the background of how I got this, but possibly it's what the learner was mentioning as a partial variations. Having had y, having 2 parts, y1 plus y2, and the first part, it's a constant. In the second part, it varies directly. Can write it aside here, y2 varies directly as x. I'm trying to communicate a direct proportionality combined with a constant term. When I feed in these equations, my y as 6.5 equal to a plus k times x that I can take as a 2. Then 5 against a plus x as 1, which is k. I will get back my a as 3.5, and I get k when I've solved them simultaneously as 1.5, which brings me to the same relationship the lady from one school there had as 3.5 plus 1.5x, which is actually the statement mx plus c. And just to confirm, if there is anyone on call and their teacher demonstrated a linear relationship that way, we can comfort them, Mr. Stefan, that that approach still leads you to the same linear relationship and expression, and it gives you the same result, just for purposes of clarity. I thank you.
Thank you so much, Teacher Lawrence, for the clarification and for the wonderful input. Okay. Kabachala. Okay. Yes, Kabachala, you were asking, I think, about the discount. Yes, the discount will be used if you are to calculate. You could use it to calculate the number that does not exceed the 90. The number that does not exceed the 90. So that's why you could use the discount by getting the what? Remember, if you are to use the alpha package, you are going to find out how many people can be invited using the package for alpha. And when you make your calculations, you will find out that the number of people is going to be less than or equal to 90. Now, after finding out the maximum number you can invite using the alpha, since it goes beyond what the question wanted for them to get a discount, then now you know that they are going to be given a discount. So you'll get the 18,000 of N minus the 10% of the 18,000 N, such that you remain with the 16,200 N. So meaning that you are going to use the 16,200 N plus the booking fee of 600,000, then it should be less or equal to the 2,220,000, such that now you know how many people will be invited using the package for alpha. Okay, thank you. So next we are going to have another school, Palabek. Palabek, unmute. Palabek, we are not getting you. Okay, I think I've failed to get Palabek. I'm going to first go back to Gombe to take us through that item 11. Gombe. Okay. I think I'm also failing to get Gombe. Gombe, unmute.
Good afternoon to you all.
Yes, good afternoon.
Share the screen. No. I don't know. I'm sharing. Can someone follow up if you're online or not? Speed really. No, not going to be speedy.
Okay. I think I'm still failing to get Gombe. Seseme. Seseme, girls. Okay. Gombe.
Good afternoon to you all. This is Omar Aruni from St. Andrew Kaggwa Gombe High School. I'm going to be presenting to you item 11 with my colleague here. Beronji Bianca. So following up from your questions that you have, it says MTN Uganda has recently received complaints from customers about delays experienced while seeking assistance from the company's help center. The management suspects that some telephone calls are taking longer than expected, which may be affecting the efficiency of the customer care services. To invigilate the matter, the data analyst randomly selected 40 telephone calls made to the help center on a particular day and presented the information on a graph in the figure 2, which you have on your question paper there. According to the company policy, the average duration of calls made to the help center should not exceed 5 minutes. Fewer than 40% of the calls should last more than 7 minutes. Not more than 5 calls should last beyond 13 minutes. MTN management wants to use this information from the graph to assess the efficiency of the help center. So the task says, provide MTN with the help they need. So following the conditions given to us, or in the question, they are the ones that it's the kind of help MTN needs. MTN wants to find out whether the average duration of the calls made to the help center does not exceed 5 minutes. If it exceeds, then it is not efficient. Going back to our work. So we are going to come up with a graph. That's first, we are going to come up with a table such that we are able to fulfill the first condition, such that we're able to find out whether the first condition is satisfied or not. Because with these conditions, it's what we shall use to be able to find out whether the many calls made affect the efficiency of the customer service helpline. So we come up with a frequency distribution table showing the number of customers and the time of call to the MTN help center. So the first thing is the minutes. So for these minutes, we get them from the graph, where the graph shows that it's a graph showing the number of customers and the time of calls. Yeah, this is a graph that shows the number of customers and the time of calls. So for our first one, which is the minutes, in other words, most of us know it as the most of us know it as the class. So we shall use that class to find out, to develop those minutes. But the reason as to why hours is going to remain the same, it is because on our graph, the numbers on the horizontal scale are the upper class boundaries. So we come up with our minutes, which is 0 to 2.5, as follows below. Then we are going to come up with a number of customers, which most of us know as the frequency. And for this, we shall get it from the cumulative frequency by subtracting the previous number, like the number after the first one, where let me hope everyone is hearing me. Going on, we move on to our next class, which is 11.5 to 14.5. We subtract 38 minus 32 for us to get the number of customers that call within that range as within the number of minutes as 6. Then our final one, we also do the same, 40 minus 38, getting 2 as the number of customers who called between 14.5 minutes to 17.5 minutes. After that, we shall generate our midpoint, which is also known as the X, by adding the minutes the range in the minutes, like the 0.0 plus 2.5. Then we are going to divide it by 2 for us to come up with this 1.52. And it's the same thing that we are going to keep on following. 2.5 plus 5.5 divide by 2, and we get our answer as a 4. We follow the same process until we come up with this. Then after, we shall go to our fx. Fx is simply the frequency times the x, which is the midpoint. So the frequency here is the number of customers. So the number of customers, which is 2 times 1.25, we get 2.5. After, we move on to the next one, which is 7 times 4, you get 28. 13 times 7, we get 91. 10 times 10, we get 100. They're not hearing, right? Mr. Host, kindly help us disable others sharing on the screen, the disorganizing the presentation.
Okay.
Then moving on forward. Yeah, thank you. Moving on forward, we total up the fx, which is 2.5 plus 28 plus 91 plus 100 times plus 78 plus 32, and we get the summation of fx as 331.5. Then from that, we are going to be able to find out our average, because for us to satisfy the first condition, which says the average duration of calls made to the help center should not exceed 5 minutes. So for the first condition here, we have to find out the average following the values that we generated from our table, whereby summation of, where first to get the average or the mean, it is summation of fx divided by the summation of frequency, which is 331.5 divided by 40, and we get our answer as 8.2875 minutes. So this means that the condition given to us by this, that means this condition was not met, because for this helpline to be properly, right, for this helpline to be efficient, the average duration of calls made to the center should not exceed 5 minutes. And these ones have exceeded 5 minutes, meaning that it is going to affect the efficiency. Let me throw the ball to my colleague, who is going to continue with the rest of the parts of the question.
Okay. Oh, some of you might be wondering how we got the values from our table. In the scenario we're given a support material. Now for the minutes, you can see we use these boundaries, the class boundaries. For the first one, we use 0.0 to 2.5, like that. There is 2.5 to 5.5, 5.5 to 8.5, 8.5 to 11.5, and so on. Now, in order to get our frequency, we first got the cumulative frequency. As we all know, an OG-based cumulative frequency against class boundaries. So we got our cumulative frequency from the graph. As you can read, if you calculate, if you go ahead and calculate, like, you can be able to locate the given points.
Yeah. We have the graph.
As we go ahead, we're still on the cumulative frequency. Then we located it from these points, the given points at the against the class boundaries.
Those points were our cumulative frequency. And as my colleague said, to get the frequency, we get the previous cumulative frequency minus the first one. For instance, here to get the 7, we got a 9 minus 2. Since, as we all know, you get cumulative frequency by consistently adding the frequency as you go down. Yeah, so that's how we got the frequency. Okay.
Use this graph.
Okay. Okay, as we go on in our scenario, we find that the second condition we have to meet is that fewer than 40% of the calls should last more than 7 minutes. Meaning that the number of calls that last more than 7 minutes should not exceed that 40% of the calls. First of all, we first got the 40% of the calls, which is 40 out of 100 times the total number of calls, the frequency, which is a 40. And from there, we got 16 calls. So our target is that the number of calls that last more than 7 minutes should not exceed 16 calls. From there, we went to our graph. Then we used calculations to locate where 7 was against the time of calls in minutes. We found that our 7 was here, around here. Right? Then to that, we followed it up to it meets the curve from, and when we calculated, we ended up getting the number of calls that last beyond 7 minutes as 15. I mean the number of calls that last for 7 minutes as 15. Now to get the number of calls that last beyond 7 minutes, we have to get the total number of calls, which is 40, minus our 15 calls that last for 7 minutes. When we found that the number of calls that last beyond 7 minutes are 25, and this does not satisfy our condition because this is beyond 40% of the calls, which is 16 calls. So typically, the second condition was not met and the efficiency was affected. We went ahead to the third condition. The third condition states that not more than 5 calls should last beyond 13 minutes. So the number of calls that last for 13 minutes should not be more than 5. We went ahead and on our graph, we located the 13 on the graph and we found it to be here where the cursor is. After that, we followed it up to the curve, and when we calculated, we found that the number of calls that lasted 13 minutes were 35. So to find the number of calls that lasted beyond 13 minutes, we got the total number of calls, which is 40 minus the 35, the number of calls that lasted 13 minutes, and then we got 5 calls. So here, the scale, for how we got that scale, we first got the intervals between these time. The scale for the horizontal axis, we got 5, like the interval between these two. We got 5.5 minus 2.5, that was 3, meaning that 2 centimeters is equal to 3 minutes. Now to get the number of minutes that each square represents, we got 3 divided by 10 and got that as a 0.3. Yeah, as a 0.3. So 0.3 was typically our magic number for the horizontal scale. That's what we were basing on to find the 7 minutes and the 13 minutes. Yeah. Yeah, so that's how we got down on the horizontal axis. Then for the vertical axis, we typically did the same. We just got 4 divided by 10 and we got a 0.4. That's how we're finding out where our minutes were. The number of customers, which is typically the number of calls. Yeah, from there, we were able to figure out, find out the second condition and third condition. We found that the third condition was satisfied since not more than 5 calls lasted beyond 30 minutes, which means less than or equal to 5 calls. So yeah, the third condition was met, but the first condition was not satisfied. So in our conclusion, we're all like, the efficiency of the whole center is affected because the first condition isn't met, since the average duration of calls, which is 8.2875 minutes, exceeds 5 minutes from what we saw in the third slide. And then the second condition wasn't also met, since the number of calls which last more than 7 minutes is 25, and this is greater than 40% of the calls which we found to be 16 calls. So yeah, that's how we were able to help the MTN Hope Center.
Getting back to you, I've seen a question that where did you get the table from? So generating this table for the part of minutes, it was developed from the graph in figure 2, which was provided to us. From that part of number of calls on the horizontal axis, or what you can call the y-axis. Let me hope everyone can be able to see this. So it is got from here. These are the values of the upper class boundary, which are displayed here. So another question that I also saw was that someone was asking, what is magic number? So in other words, every student tries to make life easy for themselves. So magic number is basically the value of its smallest box. Thank you.
Anyway, for the cumulative frequency and that table, it shouldn't be hard because we all know that an ogive is made up of class boundaries and cumulative frequency. So you typically just go to your graph, you get the cumulative frequency, to extract out the cumulative frequency and the class boundaries. Class boundaries, we all know how they are obtained. Then from the cumulative frequency, you can find the number of customers. I think I already explained that. Yeah, thank you.
Thank you so much, Gombe. We can have a question from Centenary and Mother Kevin.
Thank you, sir. My question is, why is it that there is variation in their points? For example, my question is that why is it that there is variation in their midpoint and time? Look at their graph. We are having 0 to 2.5.
Excuse me.
And in their what midpoint we are having 1.25. Yet if we are to carry out this number, we consider the interval. So from the bottom to the second first, the interval is matching, which is the Curie. But the beginning one, the first interval, we are having 1.25, which is not lining with the interval. And if it is so, if we come to consider our graph, we are having 0 to 2.5. So we cannot determine the scale. It is not ranging with the interval. So thank you, sir.
Respond to that.
Okay, over to you, Gombe.
I really do not know how I can respond back to you this question. So, Mr. Kaziba, may you kindly help me to explain this because it is becoming something else.
Hello.
Good afternoon. Hello.
Continue, go on.
Actually, my only request was that when students are actually presenting their work, it would be better they present it in a more clear way, because basing on this question, the presentation was okay, but even the explanation they used was kind of quick and rushy. So we didn't get most of their content they explained, but I appreciate the presentation they made. It's just a request.
Okay, thank you. Okay, okay. Allow me to share my screen briefly. I think the question was rotating about the midpoint. I think that's where the question was rotating. Now, hope my screen is on. So now, when you look at this item, I want to bring two things to I want to make two things clear. Number one is that whenever you are dealing with the statistics, always ensure when you are coming up with your frequency distribution table, what you are going to put in your columns must directly come from the scenario. Always the first two columns must come from the scenario. So ensure that in case they have the units, please indicate the units. Let me say, when you look at this, we had to get our frequency distribution table from here. So here they use time of course. So you write your title that a frequency distribution table showing this and this. Then from there, you're going to come up with your column. Now the first one, you'll have the time. So you'll say time in minutes. So this is, time of course. So you say time of course, and the units are minutes. That is very okay. Then after that, this side, when you check here, they use the number of customers. So you'll come here and say the number of customers. And then you put them the way you are getting them. But mind you that under the cumulative frequency, here, the number of customers are the ones that are representing the cumulative frequency. Meaning that if you are getting your frequency, you have to do the reverse. You need to know how now to go back from the cumulative frequency, and then you get back to the frequency. Now, when we are plotting our cumulative frequency curve, we use the class boundary. So when you check here, you notice that you started from 0 to 2.5. Then you went from 2.5 to 5.5, from 5.5 to 8.5, and so on. Now, I know some of us are all used, because this is class boundary. But if you wanted to get the classes, which is the time of course, then it means that you know that for when it comes to the class boundary, you subtract and then you add. So here it means that your classes would have been 0 to 2. Then here it would have been 3 to 5. This would have been 6 to 8, and so on and so forth. Now, when you are getting, I want to bring to your attention that when I'm getting now here, I will not just write X as it is. No, I'll write the maybe mid time. And then inside the bracket, I'll put X. Because you do not just put X, what does X represent? That it represents the mid time. Don't just put the number of calls. In case now it's going to be representing your frequency, then in bracket put frequency. Now when you are getting the mid time, you can, when you add 0 plus 2 divided by 2, you'll get your answer as the 1, which is very, very, very okay. Now, what do you need to know? What you need now to know is that when you are getting your mid time, we cannot have time as negative. That's why when you look here, you notice that our time, we started from 0, because we cannot have negative time. So here you cannot subtract and say negative 0.5, because realistically time cannot be negative. So that is something that you needed to take note of. But make sure that always you have your title on the what? On the graph. After having the title on the graph, clearly specify that this is a frequency distribution table. Make sure that the first two columns you have are directly obtained from the what? Are directly obtained from the what? From the graph. So from the scenario that you are dealing with. That if at all you are dealing with time, let it be time. In case you are dealing with this, let it be that particular thing that you are dealing with. So people were asking, I think about 1.25, something like that. That's why here they considered 1. But the rest of the foreign, where they will keep on flowing naturally. So that's how you could. Now, last year, it was a histogram. So mean that now you need to know how to extract data from the different graphs you have. In case you have a histogram, how do you get your frequency distribution table? If you have this one, how do you obtain? And now always also learn to read the scenario. Now for this particular one, they gave you the total number of phone calls that are to be made, which were 40. But when you look at one of these digits, you need to read it very well, because like this one was automatic, this was 2. But when it came to here, you need now to ask yourself at the end of the day, when I add everything I have obtained, does it equate to 40? If it does not, then that means that you need to go back on the drawing board and ask where the challenge was. And now here, when you are obtaining the average, you are obtaining the mean, write the formula. But like I told you earlier on, they are not going to give you a mark for the formula. However, a score is given for the right substitution of the right values in the correct formula. That is what is scored. In case there are units on what you are obtaining, like the average time, always include the what? The units. That now these are minutes, these are seconds, these are kilometers, this is kilograms. So always do not forget the units and always respond back to the item. What did the item want? That it wanted this and the other. So that is how you can deal with such. Okay. I'm saying, yes.
This is Palabakes is coming for the next presentation.
Okay.
That is item 3.
Okay, over to you, Parabech.
Okay. So this very moment, right now I'll be presenting item 3. First and foremost, I am Smart Nadiri from Palabek SS. So the scenario says, a self-employed telecommunications engineer receives requests that can be handled as
Bitch, can we work on the echo? You have an echo in the background. Maybe we can disable one of the microphones such that we do not have echo.
So you getting me well?
Yes, better now.
Okay. The scenario goes. Self-employed telecommunications engineer receives more online technical support requests than can be handled in a single 8-hour working day. The engineer provides two types of online services: network troubleshooting and software configuration. The engineer can spend at most 5 hours on network troubleshooting services, which can earn $60 per hour, and at most 6 hours on software configuration services, which can earn 70 US dollars per hour. To complete the services, the engineer uses cloud service credits purchased from an online provider. A total of 41 cloud service credits are available for the day. Network troubleshooting requests 4 credits per hour, while software configuration requires 6 credits per hour. The engineer wants to determine the most suitable combination for services that would maximize earning without exceeding the available working time and cloud service credits. So thus, they are asking, support the engineer with the information needed. So, when we look at this scenario, first of all, we have to identify, because item 3 is under pattern and algebra. So we know topics that are under pattern and algebra. So I will begin by looking at where exactly have they removed these topics from. When you look at these questions carefully, you will notice that there are words like more, at most. So these words clearly show us that this was linear programming. And also, we have also inequalities and regions. So how do we begin discussing? First of all, that's right. It is item 3. So we'll begin by giving a brief introduction to what we are going to be doing. We are going to be determining because the question said, support the engineer with the information needed. But the information that is needed, the engineer wants to determine the most suitable combination of services that could maximize earnings. We begin by elaborating, determining the most suitable combination that of services that would maximize So here we are going to be maximizing earnings. Just try to be as brief as possible. What do we begin with? Since we have identified that this is under linear programming, we begin by letting. So the scenario says that the engineer wants to determine the most suitable combination of services that would maximize earnings. And when you look at the scenario carefully, and we look at the part of earnings, it is, for instance, they say the engineer can spend at most 5 hours on network troubleshooting services without which earn $6 US per hour. So we are going to begin by letting. Let X represent hours spent on network troubleshooting troubleshooting and Y represent hours spent on service configuration. So here we are going to begin by identifying the inequalities, because for us to maximize the earnings, we will have to first identify the inequalities in this scenario, which are the first inequality will be a self-employed telecommunication engineer receives more online technical support requests that can be handled in a single hour working day. So our inequality is going to come from there, which will be x plus y is going to be less or equal to 8. Because this is the total working time he is supposed to use. So he's not supposed to what? Exceed it. Then our second inequality will come from the engineer. The engineer provides two types of services: network troubleshooting and software configuration. The engineer can spend at most 5 hours on network troubleshooting. So troubleshooting, we have let it to be what? X, which is going to be x. The inequality of at most is less or equal to 5. Then the scenario continues saying that which earns him $60 per hour and at most 6 hours on software configuration services. Our third inequality will come from that part, which will be y less or equal to 6. Then our second part, they said to complete the services, the engineer uses cloud service credits purchased from an online provider. A total of 41 cloud service credits are available for the day. The network troubleshooting requires 4, which will be 4x plus software configuration requires 6 credits per hour, which is 6y. Since they have given us a total of 41, we should not exceed that, which will be less or equal to 41. Then our last part will be finding the what? The non-negatives. Which will be x is greater or equal to 0 and y is greater or equal to 0. Then from there, we looked at part whereby they were talking about $60 and $70. So this part is gonna help us to find our what? Our objective function, which will be a combination of x and y will be equal to 60x plus 70y. And from there, we'll move on to our boundary lines. So here we can take any point that we wish to start with. For instance, we'll begin with this point. Taking x plus y is less or equal to 8. We begin by eliminating the inequality, which is x plus y equals to 8. This is our boundary line. So we'll go forward on to calculate for our coordinates. Then, here under this part, we can either use a table or you can go with the equations. For instance, you can use equations here without drawing a table, or you can draw a table, write somewhere, then write your findings in the table. Then, for instance, if we say that let our x be 0, we find out that our y is 8. Then, if our y is 0, then our what? Our x will be 8. Whereby the coordinates will be 0, 8, and 8, 0. So that is our first coordinate inequality. Then the second inequality will be taking x greater or equal to less or equal to 5, which will be x equals to 5. Then our next one will be taking y less or equal to 5, which will give us y equals to. Then the second inequality, this one was 6. The now second inequality was 4x plus 6y is less or equal to. Then for that, we'll go with 4x plus 6y is less or equal to 41. Then we move the inequality sign, which is 41. That is our boundary line. 41. Then again, we'll be finding our coordinate here. Now, here, we'll begin by letting, if x is 0, if x is 0, y will be 6.8. Then for this part, if y is 0, you find out that it will give you 10.25, which will be rounded off to 10.3. So for this session, we try to find out different values that couldn't give us what? Decimal places, but we kind of failed to get them. So we decided to take these what? These points, which will be 0, 6.8, and here it will be 10.30. Then last, you should not forget the what? The negatives. So the non-negatives, whereby it will be x equals to 0 or y equals to 0. So having found our coordinates, we have to go for our what? Our graph. So under this part, I will have to, I don't have the what? The soft copy of the graph, but I'll try to elaborate more on how this can be done. So for those who have graph papers, you can follow me. So for instance, we begin by what? We are going to get which a graph should be with the title. That is the first. The key thing that it should not be it. So if you are writing your title, always make sure that the title that you are writing corresponds with what you have laid. So we say that graph showing hours spent on network troubleshooting and hours spent on service configuration. Then having stated your what? Your title, you will have now to go for your what? For your actual graph. But before you draw your graph, make sure that you know where your what? Your hours spent on network configuration are gonna be, and also what? Your hours spent on service configuration are to be. According to our elaboration, how we let the thing to be. So these are our axes. Never forget with these arrowheads, whereby this is gonna be y-axis and this is gonna be x-axis. Now, having done that, we'll have to first get a reasonable scale that will have to best suit our values that we have got. For instance, if you look at our boundary lines that we have managed to come up with, and we look at our y-axis, the values find the y-axis, you will find out that the values here, 8 is the largest. So I know a graph like you have, it is measured in what? In centimeters. So, but try your best that at least your graph covers like a quarter of your what? Of your graph book. So for instance, your graph paper. Let us say that this is your graph paper. This is your graph paper. Try to see that if your title is here, your graph, if you plot everything very well the way it is, at least it should end somewhere here. If you decide to take what? 1 centimeter represents represents 1 on our vertical scale. We find that our x-axis, if after drawing our highest, it will stop somewhere here, which will not be what? Reasonable. So we can adjust our scale, whereby you can say that vertical scale equals to 2 centimeters represent distance to our town. These demarcations that were supposed to be expressed, we are beginning from 0. Now from here you count how many. First we have what? This small box, the big box, for instance, one that has 1 centimeter and one here on another centimeter. So since we have taken 2 centimeters, we are going to cover two boxes at once. Now, for instance, this we are going to begin here to give a difference here, which is going to be 3. Another one, which is going to be 4, 5, okay, 6, 7, 8, 9, 10. Can even exceed that. So, but make sure that you have 2 centimeters in between them. Now, when it comes to our vertical scale, our horizontal scale, you will find out that the horizontal scale has limited what? Like the big squares, they are limited. Then what you do, you look at your highest value is 10.3. That is our highest value there. Now here for it, we can use 1 centimeter representing 1. The reason why I'm doing this is because I want my graph at least to cover reasonable what? Space onto my graph paper. Now, for instance, here to be 1, 2, 3, 4, 5, 6, 7, 8, 10. Since it is 10.3, we'll have the exceedance. Ahead. Now, we go to our plotting now. For values that don't have at least decimal places, they are easy to plot. For instance, taking our boundary line BC, which is, remember, it is always x to y. Come on your x-axis, read it down. Then your y-axis is 8. Put a star, mark that point. Your second coordinate, which is x to y. Now x it is 8, then on our y it is 0. Now, if this was like less without equal to, we have used that slide here to change this one. It's called itself. But since we have equal to, it has to be what? Outline. Now, come and these 2 points. After joining, don't forget what? Name the line that you have what? That you have drawn. Which is, we use the boundary what? Like, don't use one. Which is plus y equals to a. Now, how do we shade? if you see like you have for instance, an equality sign, less than or equal to. Just look at that equality sign. This one is missing. Come on your line that you have drawn. 8 going down. We are going down, you will find out that the value is down here at less. It means that this one satisfy what? Our condition. So we have to shade what? Reduce the volume. But while shading, try to make sure that the difference between these lines, at least the space is equal. Now, having done that, you come to your second what? Boundary line. Taking y, taking x, let's go equal to 5, which is x will be here. Output will be there. Now, line that is on it will just draw a line that is standing what on the x value above being provided with. So remember, no, it is a bold line because that's what it's time. So the first line from up touching that point there. So never forget what elaborate the line that you have drawn, which is x equals to 5. Then don't forget the trick of shading. Just look at the equality sign. Come on, show point. Here, 4 is less than 5. So what you will do, you have to shade what? This side, because this side is greater. Now, from there, we go to our next line, which is y equals to 6. 6 is here. The y-axis, we draw a line that is horizontal. It is less or equal to, it means we are shading the upper part. Now, for the line for 4x plus y equals to 41, our coordinates were these. Here, since we have what? Decimal points here. What we'll do is simple. Here it is 6.8. We come on our line. It is 0 on the x-axis, then 6.8 on our what? On our y-axis, which is around somewhere here, between 7 and 6. Then, what we'll do, it is 1. Look at our scale that we have used. For instance, we have used on our vertical scale, vertical axis that 2 centimeters are representing 2, whereby it will be that it is 2 hours. Now, if you look at this very well, what you will do, just count the number of small squares in that range. For instance, if it was 1 centimeter, would have counted the what? Those number of small squares. Now, for 2 centimeters, it means it's going to be a total of what? Of 10 smaller squares. Now, what you will do, you will divide this value. For instance, we have in 2 over 10 to see how many number of small squares are there. Like for instance, this was the 1. This is supposed to be what? 1. When you divide, it will be 0.1. Since we have the 10 small squares here, you will count that from here to the next small square, it is what? 0.1. Then look at this, it is up to 6.8. You count up to around like here. Put your point there. Now for that, this coordinate will be 10.3 on the x-axis, on the y-axis it is 0. It's going to be between 10 and 11. So here we use that 1 centimeter represents what? 1. So we divide 1 by the small squares in 1 what? 1 centimeter, which are 5, giving you 0.2. So it means if you count from here, starting from here up to here, it is 0.2. Then to your next small square, you find out that it is 0.5, meaning that it is around here. So what you will do, you have to join your points that you have got, which are here. Then don't forget also to name that line. Then for the next part, you have now to test, which is less or equal to that. Means that this side is the one that is greater. So you find out that, don't forget in the non-negative. So you have to at least show that you have shaded them. From there, you find out that your feasible region is here. Now, since they have said that, the question was saying, help the engineer to most suitable combination of services that will maximize earnings without exceeding the available working space. You go and take points. You look at it where these lines have intersected at a certain point. If you find out that the line that has they are crossed, but they have not passed, like for instance, at the point joining here, and here they have passed around me, the line has passed where there is no point. If that line go to the what? The point that is next to it, that what? Coordinate. Now, according to our finding, we found out that if and someone will have the coordinates. You're right. So, sorry about that. We found that our corner points are gonna be 5, 3. That is the first corner point. The second one is 1, 6. The third is 0.6, and another one is 5.0. Another one 3, 4. Try your best that always you find at least your minimum is supposed to be at least 5, your maximum at least 5, 6. Then, okay. Now, using our objective function, you will have drawn your table showing point C and objective function, whereby you have now to substitute where there is X with the value that is here, and also where there is Y with the value that is corresponding. Now, you find out that if you take this point, it's gonna give you 5, 1, 0. Take this point and you get 4, 8, 0. You take this point, 4, 2, 0. If you take this point, that is the amount you are getting, and also last this point, 4, 6, 0. Since we are maximizing, we are taking. There's no comma in between. Like we are taking the highest value. These are what in dollars. So you will see that 5 and 3 are giving us what the highest value here, which is 510 US dollars. Then after finding that, you have now to go. So they said our conclusion is supposed to respond to the item, determining the suitable combination. We will say that the suitable combination of services that could maximize earnings without exceeding the available working time and cloud service credits are 5 is on what? On network troubleshooting. So it's gonna be 5 hours spent on network troubleshooting, and also 3 hours spent on what? On service configuration, which will give us this amount. So, according to that, even if you add these points, you find out that if you add 5, they are giving us a maximum of 8, which is the total work this person has. Any questions? So at this time, I would the questions. So anyone who has a question, according to the we need more elaboration, you are free to ask.
Okay, let's start with Mother Kevin.
Okay, thank you for the opportunity granted. The first line of the sentence says, a self-employed telecommunications engineer receives more online technical support requests than can be handled in single 8-hour working day. When he was elaborating where the boundary line was, he took it as X plus Y is less or equal to 8. We request him to highlight us more about how that question came about.
Unfortunately, not
And
very audible. We can't hear you.
Extend.
the first line of the sentence says, a self-employed communications engineer receives more online technical support requests than can be handled in single 8-hour working day. When he was calculating the boundary line, he said taking x plus y is less or equal to 8. Would you request him to highlight us more about how it came about? And another one, while we're told, while shading the graph, we're told that when you are shading the unwanted region, you have to make
Getting the
sure
question.
that you're shading. Another, and we're told that when on the graph shading the unwanted region, you have to make sure that your shading
Will you keep quiet?
covers.
We can continue.
Oh, we have lost Mother Kevin. Parabeg. Okay. Mpoma School.
Yes, this is the formal school. So coming back question is it really necessary for us to put the title and also the scale? Because first our teacher told us that it's not really necessary. But here I'm seeing most of the graphs that they are drawing, they're including the scale and the title. So is it really crucial? That's my question.
Okay, I think we are failing to get Parabeg, unmute. Parabeg. Are we failing to get Parabeg? Okay. Okay, I think I'm failing to get Parabeg. Okay, allow me to just throw some little light on. Now, I want to highlight a few things on this element of construct such that we do not make the same errors. Now, some of the issues when handling this particular item, one of the mistakes that students do is having wrong inequality symbols, failure to obtain the feasible region, not being able to know what points you are going to choose as your optimal points. Dear students, when you find that the line you are doing is not a bold line, let me say you are doing something like this, we do not expect you that you are going to choose a point from this region where you have the dotted what? Dotted lines, because this is not part of the solution. So in case your inequality is greater than or less than, we do not expect that you are going to choose any point along this point. But we shall expect you that the maximum or the minimum can be chosen from the bold lines. It can be along the line as long as that line is bold. If your region is bounded by only, by what? By only dotted lines, then that means that we do not choose any point. However much they are meeting at these points. We do not choose any of those points because this is not part of the solution. But we shall expect that we choose points within the feasible region. Then also the scale that we are using. Always ensure that the scale you are using is a consistent what? Is a consistent scale. Do not just choose things anyhow, but ask yourself whether I can have a scale that is consistent. That if you are using a scale of 0, 2, 4, 6, 8, this is okay. Make sure that in between the two digits, you have the same what? The same value. That here there is 2, 2, 2, 2. But don't start from 0, you go to 2, you go to 3, then you come to 6, then you go to maybe 7. Then here, the scale is not going to be consistent, meaning that the values you are going to get at the end of the day, they are not going to be correct. Then clearly, what are the do's? Clearly, make sure that you define the variables you are going to use. Define, and I want to give you a hint that always what comes first in the item. Let me say they have mentioned network troubleshooting. Let it be your X. Let X equals to the hours spent on networking troubleshooting. Let Y be the hours spent on software configuration. And then from there, you come up with your inequalities. So first have all the inequalities. As you have extracted them from the scenario, write them before you go on to reduce them. And ensure that always you have 2 or more points that can be plotted. Now, if you want to maximize scores on this item, then you need to do the following. Ensure that when it comes to your working space, you have clearly defined your variables, you have the non-negative inequalities where they're applicable. Equations of such x is greater or equal to 0, y is greater than or equal to 0. Sometimes they may apply, sometimes they may not apply. But these are what we call the non-negative inequalities. Always have them there, because at the end of the day, we cannot have a negative x, we cannot have a negative y. Meaning that even when you are making your graph, avoid having a bigger space for negative and a bigger space for what? For negative this side. No. Make sure that you leave very small space for negative and very small space for positive. In other words, your graph should be well. In case this is, let me say, this is your graph, then make sure that you use the biggest space. That let it just be here 2 centimeters maximum, and then here you can have 2 or 1 centimeters, but don't leave a very big space for negative or positive, because you do not need them. Then make sure that your boundary lines are clearly labeled. And when you are labeling, in case your equation is x plus y is equal to 8, please put it there. Do not avoid labeling your graphs with such inequality, whereby you find someone has drawn the graph but has labeled it like this. So please do not label your graph work with inequalities, but always will label with equation. Have your table of coordinates and extract the coordinates where you are going to be meeting inequalities, whereby you are getting points. Ensure that for you to be accurate, have quite a number of points. At least have 4, such that your points are well, but not just stick to 2. A case in point, like when you look at this item where you had 4x plus 6y was equal to 41. Here, do not only use the 2 points, that when this is my x and this is my y, when I put in, let me say 5, I get 3.5. When I put in maybe 3.5, I get this, and so on. So here, do not stick to only 2 points. That let me say when x is 0, I get here, always better have a number of points. At least have 4 points, more so where you are getting the decimal points. But where you are getting points that are not decimals, then that is okay. You can use the intercept approach. And always extract the coordinates. After coming up with your table, extract the coordinates and write them that I'm going to be plotting 5 and 3.5. I'm going to be plotting 3.5 and 4 point what? 4.5. I'm going to be plotting 0 and 6.8. So extract the coordinates that you are going to be plotting, but don't just read them directly from the table without extracting them. When it comes to the graph, make sure that your graph is clearly labeled. Label it very well that this is y-axis, this is the x-axis, and then define what is contained along your axis. That may be this axis. Along the y, I have the hours spent on software configuration. This side, I have the hours that are spent on networking troubleshooting. Even have a title that this is a graph showing the feasible region. And make sure that your points are correctly plotted. Have your points correctly plotted. Have the lines well drawn, because those are the things that are going to earn you the scores. They look at this, that your axes are well labeled, that you have defined your scale. Your scale is consistent for the values. You have plotted and joined the lines very well. The lines have been labeled. The shading of the region is okay. Because now when it comes to this item, we always look out for, as the person labeled the axis, that yes, as this person being able to define what is contained on the axis, yes, how is the scale, what scale, that the scale should be appropriate. Yes, the scale is appropriate. And when you are labeling your scale, make sure that in case your values are stopping, let me say at 10, and here maybe the value is also stopping at 12. Please do not have a very redundant space this side whereby you have added 14, 16, 18. No, these ones are not needed. Don't go far beyond what you need. So always just make sure that you stop, or you go just beyond just 1 point, but don't go beyond what you need or what you are going to plot. Make sure that you plot and join these lines. Make sure that you name the lines immediately. That what line is this? That this line is x plus y is equal to 8. So label the line, because those are the scores that are going to be given to you. When you look at the syllabus book, you will notice that when it comes to labeling axis, when it comes to scale, when it comes to plotting and joining the lines, when it comes to naming of the lines, all this is senior 1 work. This is what you cover in senior 1 work. So all these are scores that are being given to you. It is only shading of the region that will bring in the senior 2 work, whereby you need to know which side to shade and which side not to shade. But always we shade the unwanted region, the region that does not satisfy the inequality. And when it comes to maximizing, always look out for those sharp points, or where the two lines are meeting, given that the lines are body lines. But if lines are broken lines, then we do not expect you to have it. Then also make sure that you read the points from the feasible region. In case the dotted lines, then you can get a point that is very close to that particular line. Now those are some of the key things. But also you need to be very careful with the wording. There are different words they can use. So this table gives you some of the phrases that can be used in the scenario. And then you need to know which word am I going to use? Which kind of inequality am I going to use? In case you find things like, let me say you have found less than, then you need to know that under less than, what kind of other words can they use? They can use the word below, shorter than this. In case it is greater than, which other words can be utilized? In case it is greater than or equal to, which words can be used? In case it is less than or equal to, which words? Then you check out that for greater than or equal to, what are some of those common words? Words like at least, words like minimum, not less than, not below. And whenever you find a negation statement being used against a word, then do never forget to put an equal. Let me say not less than this, not more than this. Then that means that one you'll have to use an equal on that particular sign that the negation words are accompanying. Now these are some of the common words that you can find being used in the scenario, such that you know which kind of inequality is going to be corresponding to that particular thing that you are working out. Yes. To how many decimal points should we round off? Now in case you are going to plot, you are going to plot one decimal 1 decimal point is okay, because your graph, you may not be able to estimate more than 2 decimal points. So just write, in case, let me say you have got 4.2, maybe 4.89 here, just approximate this to 4.9. So when you go to your graph to plot, let me say this is where maybe 4 is, and this is maybe 5, and here maybe you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you just approximate, and then you can, depending on how you are drawing it. Which side do we write the inequalities? Always, I encourage that write the inequalities outside the feasible region. Let me say you have finished your graph, you have finished to draw. Let me say like this. Let your equations you are writing, don't go into the region here. Don't write them here. Just label them as long as you have labeled your line, that this line is this line is this and this line is this. But also I want to warn students that there are lines you are going to meet whereby the lines do not have the intercept. So for such lines, please and please do not go on and say, I'm going to use the intercept form. When my x and y is 0, you'll find yourself getting what? 0. Now for such lines, please, dear students, create more values of x. Say I will use 1, I'll use 2, I'll use 3. And then go on and get those values from the equation. Most so when it does not have the what? The C part. So for those ones, create more points, and then after, extract your coordinates from there. So these are some of the things that you can. Do we write the word feasible region? It is okay. Someone can decide to put here that F is my feasible region. In case you want, in case you have plotted and you have said that a graph showing the feasible region, that one is also very, very okay. But like the school has told us, make sure that you extract at least 6 points or 5 points, such that you can test them to check out which one is the best to use, or which one minimizes and which one maximizes. So understanding the scenario is very key. Understanding the scenario is very key, such that you know what kind of thing you are going to do. Are you minimizing or are you maximizing? And always we shade the unwanted region, unless otherwise, but always we shade the unwanted region, and never forget to extract your coordinates and show even how you are calculating for those particular points. Okay, so allow me now to invite, we are going to invite another school. We are going to invite another school. Okay. Just a minute. Selele, kindly prepare. You're going to be the girls' school. You are going to be the next to present. You are going to be the next to present. Now, I want you to also take note that sometimes you may find these scenarios whereby they have used a word such as, let me say, they can tell you that he has a total budget of 5,000. Now, when you look at the word he has, you may ask yourself, which inequality am I going to use? What does it mean? If they say that someone, that's the amount he has, it means that that amount cannot go beyond that. So when you find such wording, like he has a total budget of this, he has this, then we expect you to use less than or equal to, because that amount cannot go beyond that. If they tell you that he has 180,000 available, it means that the amount he has cannot go beyond that. So that means that you are going to use less than or equal to, because it's something that the person, that's what is available. So that means that if that's the only amount you have in your pocket, you cannot go beyond that. So that one we expect to use less than or equal to. So that one, please take note of it. In case you meet it somewhere, then you need to know what kind of inequality you can use. Most so when they use the word has, this is what is available, it means that you cannot go beyond with what is available. In case a given budget has been allocated to you, you cannot be in position to go beyond that particular budget. So you have to work within the budget that has been given to you. So that one, please take note of such wordings in case they are being used in the scenario. Okay. Okay, Seseme, kindly unmute. Seseme, we are waiting for you. Kindly unmute and start on the discussion. Oh. Are we failing to get Seseme? Oh. Okay, I think I'm failing. Moyo, SS. Moyo, unmute. Am I failing to get Moyo? Oh, I think I'll fail to get Moyo as well. Moyo. I don't know whether Kihi or Parabek we are set. Seseme, you are saying you are ready, but I'm failing to get you. Sememe, can you talk? Okay. Okay. I think I failed to get Seseme. I'm failing to get Moyo as well. Let me check on Mamba. Oh, Mamba, are you ready? Mamba? Okay. Okay. I think we are failing to get. I don't know that Kihi High School. Okay. Poketo? Paloketo?
Excuse me, sir.
Yes.
Oh, he's not.
Come again, Chihi.
Mister, I have a question.
Okay, yes.
By the good afternoon. So our teacher told us that when you make good
Come again.
afternoon,
Good afternoon.
I'm having a question about
Hmm.
the last item. I have a question. I have a question. Recently, our teacher told us that when you're labeling a graph, you don't put x-axis, you just put the content. Okay, our teacher told us that when you're labeling a graph, you don't put x-axis or y-axis. You just label the content that is given in the scenario. Either you're letting for vehicles, then you put you put vehicles, yeah, on the axis of x. Thank you.
Okay. Now there are two things. There is what we call labeling and then defining what the axis contain. Now labeling, you just put the y, that this is y-axis, this is x-axis. Then defining what your y-axis has is you put the word that this one is this and this one is this and this. Hope that's okay. That here Along the y-axis, I have hours spent on software. Along the x-axis, I have the hours spent on network troubleshooting. That is defining what the axes contain. Okay. Okay. Bujuko, can you unmute? Bujuyuko?
Yeah.
Okay. Okay.
Hello? Yes, I'm there.
Yes. Bujuyuko, which item are you going to present?
You're going to be presenting item 15.
Okay. Kindly take us to item 15. Bujuyuko, take us to item 15.
Good afternoon.
Good afternoon to you.
Good afternoon. We are going to be going through item 15. Good afternoon. We're going to be going through item 15, the first item under geometry and measures. The item reads, an inspector of schools traveled from his home at 6 a.m. to inspect a certain school. He first traveled in the direction north 60 degrees west at an average speed of 8 kilometers per hour and reached a trading center at 8:30 a.m. After resting for 15 minutes, the inspector continued his journey in a bearing of 250 degrees at an average speed of 150 kilometers per hour and reached the district headquarters at 9:33 a.m. He then spent 10 minutes in a meeting with the district education officer before traveling directly to the school, which was 40 kilometers away from the headquarters. The inspector arrived at the school at 10:02 a.m. At the school, the inspector supervised lessons for 2 hours and later met the school administration for 1 hour and 30 minutes. After the meeting, the inspector traveled back to the district headquarters to submit the inspections or submit the inspection reports. After submitting the reports, the inspector was informed that he could either, the first option was use the route through a trading center to return home, or go through the school and then use the direct route from the school to his home. The inspector's vehicle had 35 liters of fuel at the beginning of the journey, and the vehicle consumed 0.06 liters of fuel per kilometer traveled. Task. The part A is advise the inspector on the better route to use when returning home, give reasons for your answer. And part B is give reasons for your, part B is determine whether the fuel available at the beginning of the journey would be enough for the inspector to complete the entire journey using the better route. Give reasons for your answer. So here's a summary.
So before we respond to the item, we need to make a summary of the information given in the scenario. So, as I summarize, the starting time of the whole journey was 6 a.m. He traveled and the time he reached the trading center was 8:30 a.m. The time spent traveling between the home and the trading center was 2 hours and 30 minutes. The speed between the home and the trading center was 80 kilometers per hour on a bearing of north 60 degrees west. The distance from home to the trading center is 200 kilometers. We obtained the distance from distance is equal to speed times time. Since we had that time, we just had to find out how many hours are between the starting time and the time he reached the trading center. So we obtained that and multiplied speed time with time. And we got 200 kilometers. The resting time was 15 minutes, and then he continued at 8:45 a.m. The speed between the trading center and the district headquarters was 150 kilometers per hour. Bearing from the trading center to the headquarters was 250 degrees. The duration of travel was 48 minutes.
So to get the distance between the trading center and the headquarters, we use the formula distance equal to speed times time. But then in this case, the time was in minutes, which was 48 minutes. And since 1 hour equals to 60 minutes, I used 48 over 60 times times the speed, which is 150 kilometers per hour. The answer at the end of it all was 120 kilometers. Then the time between the HQ and the school, the headquarters and the school was 10 minutes. The 10 minutes we spent them in a meeting with the district education officer, which ended at approximately 9:43 a.m. But all that seems relevant. So now we go to the distance between the headquarters and the school, which is 40 kilometers. So this is a sketch of the entire journey, starting all the way from his home to the trading center. No. This is the summary of the journey all the way from his home, which is let's come back. Yeah, so first need to get the total distance traveled, which in this case you're going to have to add the distance traveled from his home. Suppose get the distance from his home to the trading center, from the trading center to the headquarters, then from the headquarters to the school. Then after doing all of that, after doing all of that, they said that from the school, he traveled back to the headquarters to show the executive officer the results, meaning in any case, why is the slide moving? So in any case, you're supposed to find the route as well. That could have been the option if he used the direct route from the school back to the home. According to the sketch and according to the scenario where they said from the headquarters, he moved directly to the school, it means that if he's taking one direction, he'll continue in that same direction in order to reach the school. That is why the bearing was not given to us. Therefore, if that is how it is, you come out with something similar to this. This is a non-right angle triangle, which has the 30 degrees as one of the interior angles, 130 degrees, and another interior angle is not known, but it is similarly not necessary. One side has 200 kilometers, 160 kilometers, and another side is unknown. All got from this, whereby the 200 is the distance from the home to the trading center, Then the 160 comes from the distance from the trading center all the way back to school, which constitutes for one side in the triangle. So following the sign rule, whereby sine A out of sine A equals to B out of sine B equals to C out of sine C, we chose two different sides, allocated one side A and allocated another side B. In this case, the A is going to be the unknown, the length X here. Kindly forgive me for the interchanging of variables. Yes, kindly forgive me for the interchanging of variables. So the X is going to be represented by the A, and the B is going to be the 160 kilometers, while the angle, the capital B, is going to be the 30 degrees. So just substitute into the formula, A out of sine A equals to B out of sine B, whereby A is supposed to be the X, so A out of the sine of 130, they're opposite, so that's how we take it. It's going to be equal to 160 out of sine 30. 160 out of sine 30 in the next step gives you the answer of 320. Supposed to be kilometers, but we're going to bring in the values at the end of it all. So A out of sine 130 degrees is going to be equal to 320 kilometers. So to eliminate the sine 130 from the side of the A, to make A the subject, we're going to have to multiply the sine 130 on both sides. By doing that, in the last step, we see that the value of A, which is the direct route from the school to his home, got from this slide, is going to be 245.1342218 kilometers. That constitutes for the direct route from his school to his home, the route that the inspector informed him of. However, the distance covered when returning through school, given the fact that he had to go to the headquarters to return the results, it means that he's going to have to move from the headquarters to the school, then from the school directly to his home, which means that the total distance traveled is going to be the distance from headquarters to school plus distance from the school to the home, which is going to be the 40 plus the 245.1342218 kilometers, giving me a total distance of 285.1342218 kilometers. Then, in order to give a comparison, you must have both distances to give both values. That makes it seem more logical when explaining. So you must also find the distance traveled when returning to the trading center. Therefore, he moves from the headquarters to the trading center, then back home, the same route he used when arriving in the first place. So the distance is going to be distance from the headquarters to the town council, plus the distance from the town council all the way back home, which is going to be the 120 kilometers between the headquarters and the town council. This was got using the equation from earlier on, distance equal to speed times time. Then plus the 200 kilometers got from the same equation, although with different values. This gives me a total distance of 320 kilometers when returning via the trading center. Therefore, in relation to the scenario, where they say in part A, advise the inspector on the better route to use when returning home, logically, you'd want to use a route that is faster, shorter, and so many things. So your conclusion should have the decision plus the reason. In this case, the conclusion is he should use the route through the school because it has a distance of 285.1342218 kilometers, which is less than the distance through the route of the trading center, which is 320 kilometers. That is the conclusion for part A, and therefore I'd like to give my colleague to continue with part B.
Okay, so item 15, part B. We start by giving a subheading to allow the examiner to understand our work very well. So our subheading was determining whether the fuel at the beginning of the journey is enough. So we started by finding the total distance, the distance from home to school and then to the headquarters. And the distance was obtained from 200 kilometers plus 120 kilometers plus 40 kilometers and then plus 40 kilometers again. Now, it can be seen here. We first move from home, from the headquarters, from home, there are 200 kilometers, which lead you to the trading center. And from the trading center, we have 120 kilometers, which take you to the district headquarters. From the district headquarters, he moved for 40 kilometers to reach the school. And then when he was at the school, he finished his work and had to go back to the district headquarters. So that accounts for the first distance we found. So I guess that's more understandable now. The total amount of fuel used. Since 1 kilometer consumes 0.06 liters of fuel, the 400 kilometers that took them the first journey will consume 400 times 0.06 liters. And the answer will be 24 liters. So we had to find the remaining fuel after the first journey. And the remaining fuel was obtained from total fuel used minus the total fuel minus the fuel that was used for the first journey. And that was 35 minus 24 liters, giving us 11 liters. The fuel required when using the beta route. The beta route was the route which had 285.1342218 kilometers. And we multiply that by the amount of fuel required for 1 kilometer. And the answer we obtained as 17.11 liters. So now we had to find the difference between the required fuel and the remaining fuel, just for the extra marks. So after obtaining that as 6.11 liters, it shows us that that is how much more fuel they required when, like, if they are supposed to successfully go through the entire journey, which means that the fuel they had at the start was not enough. And for that reason, we concluded that the fuel available at the beginning of the journey will not be enough to complete the whole journey using the beta route, since 6.11 liters more would be required if the journey was to be completed successfully. Thank you.
Let's respond to a few reactions.
Okay, thank you so much. Let's have Church of God High School. You could ask. Okay. Church of God.
Now there. Yes.
Continue. Okay. Thank you so much, Church of God. Thank you so much for the presentation. I'm going to just make 2 comments when it comes to that element that has been discussed. Dear students, when we are dealing with that area, there are a few things that you need to take into consideration. That you are dealing with geometry and measures. Under geometry and measures, there are things that you need to look out for. In case the item you are dealing with involves, let me say, coming up with a sketch and the rest of that. So number 1, you must ensure that the sketch you are coming up with is a collective sketch. When we are sketching, some of you, for you just make a sketch, you say, that is a sketch. And how do you do it? You just come, let me say you draw a sketch. Let me say you come, like, let me say this is your sketch. You come here, you say this is 4, this is 8, and maybe let me say these are kilometers, this is 4 kilometers, and maybe whatever. And you think this is okay. Much as it is a sketch, this one is not mathematical okay. When you are coming up with a sketch, ensure that on the sketch, in case you have mentioned 4 and 8, let it be proportion that the distance of 4 kilometers and 8 kilometers, your 8 kilometers cannot be less than 4. So make sure that even if it is a sketch, you clearly show that your 8 is bigger than what? The 4, that this can be 4 kilometers and this one can be maybe 80 kilometers. Let us have the proportions shown that 8 is bigger than 4 when you are making your sketch. Don't just draw anyhow, thinking that everything is okay. Even if you are indicating the angles, if at all you are drawing an angle, you say this is 60 and maybe this is 30, then there make sure that you are proportion. We do not expect you to have a 30 angle bigger than the 60. So make sure that whatever sketch you are coming up with, the sketch should depict what you are going to do. The sketch must show what is it that you are going to do. Don't just draw for the sake. So indicate that a sketch showing this and this, and then from there you can go on and do other things. So under this element of construct, geometry and measures, you must be able to analyze the information and follow the instruction. In case it comes now for things concerning the bearings, we expect that you are going to come, let me say this is your bearing, and now you are going to come and indicate. Let me say you are indicating 130 degrees. We do not expect you to come and say, because some of you sometimes, when you, let me say those are your degrees, you will come and say, my 130 degrees is here. Then you come and say, this is 40 degrees. Now, members, this is not a right 130 degrees. We expect you to come and say a right one, that this is maybe 140, and then you clearly show that this is 130 degrees, but not showing that just the 40. No, clearly show the bearing that it is 130 degrees. So the angle and the distance should clearly depict what is going to happen on the accurate drawing. So make sure that those things are matching. Now, in case it comes to bearings and geometry, units are very important. Make sure that the units of measurement are indicated. In case you are putting back your response, you are getting your result, never forget the units, unless when the units have not been mentioned. But the moment you see units, let's have the units being indicated there. Very, very well. So that is very important when you are dealing with this. So under geometry and measures, there are some concepts that you need to know. Concepts such as finding the surface area. Those are key concepts you need to know. Like when you want to measure the material of something to put. In case it comes for things of volume, they will ask you, how much ice cream do we need to put there? Then you need to know that this and this is what I'm going to be putting in there. So here, make sure that you know what to do in those things. So we expect cities under geometry and measures, where we are going to expect that when you are drawing your accurate diagram, let's have it on the graph such that you are very accurate. Have your final diagram, let it be on a graph such that your values are very accurate. Because you know the measurements we have on our graphs are going to be accurate. UNEB graphs are very accurate. However, some of the rulers you have in your geometrical sets are not accurate. Some of the protractors are not so accurate. So make sure that the things you are dealing with are accurate, and let's have them on the graph. But still under this element of construct, please just know that here there is real life for application. When you find these things, for you do not look out, don't just look, because many of these things are applied in real life. When you look at the scenarios that have been said, you do notice that many of those things, we picked them from real life. I know there are some numbers, those who have read, there are some numbers that you may have noticed that we picked an item from real life, things that you have kept seeing. Like I know there is one of the item, I hope one of the schools is going to do them. Like many times when you're moving across, sometimes you see such, there is an item there under geometry and what? And measures, because this is real life. So this is what we looked at when we are setting that item. There is an item on geometry and measures. It is item 19. This is now the picture you need to have in the mind. And this is what we are looking out for, that someone was transporting maize from one area to another. So this is the thing, the idea you need to have at the back of the mind. How does it depict itself in real life? How does it look out like in real life? So item 19, it is this that we are looking out for. So geometry, whatever thing you are doing under the competence-based curriculum, you must relate it to real life. That there is a concept within real life where you can apply that knowledge that you are learning in school. When you are learning about surface area in schools, the cars I have showed you, that is where you are going to apply them. When it comes to putting, let me say, tiles in home, the knowledge you are using is the knowledge of areas. When it comes to looking out what you are going to package, the packaging material to put on the surface, that is the knowledge of what? Of areas. When you come to putting, like you want to sell some things, let me say milk, you want to sell water and the rest of that. Now that is the knowledge for volume. So now learn to relate to real life. Whenever you read the scenario, make sure that you go back and look out for what does it represent in real life. How does it look like in real life? So those are a few things that we need to look out for. Okay, thank you. Seseme, are we set? Seseme? Oh, I think Seseme, we have failed to get you. Seseme?
We are ready.
Okay.
Sesame goes, looking present. It reads. Achira Sugar Limited supplied premium sugar.
Okay. Seseme, you can have the phone, first adjust the phone such that you can have it in the horizontal mode. First adjust that phone. Go to the phone and then change the orientation. First change the orientation for the phone. Perfect. Perfect. And can you have now the question first displayed there? If you have the question, hard copy, first place it there and read, and then we start.
Achira Sugar Limited supplies
I'm going
premium.
Seseme, I want us to, you mute the other microphone. Seseme, go on.
Achira Sugar Limited supplies premium sugar.
Okay.
Supplies
Go on.
premium sugar to supermarkets across Uganda. The sugar is packed in bales containing small household packets and in bags intended for bulk purchasers. At the beginning of June, Kachila Sugar Limited supplied mega supermarkets with 25 bales and 10 bags of sugar. It supplied mega supermarket with 25 bales and 10 bags of sugar. During the same period, Quality Supermarket received 30 bales and 6 bags, while Capital Shoppers Supermarket received 15 bales and 12 bags. Kachila Sugar Limited charged a wholesale price of 80,000 shillings per bale and 220,000 shillings per bag. At the end of the month, Mega Supermarket reported selling 22 bales and 8 bags of sugar. Quality Supermarket reported selling 28 bales of sugar. In addition, 2 bags were damaged during the storage and could not be sold. Capital Shoppers Supermarket reported selling 14 bales and 11 bags of sugar. So we have our information here. They are telling us that at the beginning of June, Mega Supermarket received 25 bales and 10 bags of sugar. The Quality Supermarket received 30 bales and 6 bags of sugar. Then Capital Shoppers Supermarket received 15 bales and 12 bags of sugar. So we decided to use a table so as to make our information neat or to make our work neat. We are seeing here we have supermarket. Wait, first of all, you have to first indicate a title on that table. A table to show the supplies made by Kachila Sugar Limited at the beginning of June. Kachila Sugar Limited supplied Mega with 25 bales and 10 bags. Quality Supermarket, 30 bales and 6 bags. Then Capital Shoppers, 15 bales and 12 bags. Then the prices for each of the items in Ugandan shillings. So here we are going to use matrices. So here we are saying that you formulate matrices for supply. Matrices for supplies with their prices. Now the supplies here are Mega Supermarket received 25. Then 25 bales and 10 bags. Quality Supermarket received 30 bales and 6 bags. Then Capital Shoppers, this is Capital Shoppers, received 15 bales and 12 bags. Then the prices are also here, the matrix for the prices. The bales, 80,000 shillings, bags, 220,000 shillings. Then remember in our question, Part A, they say that organize the supply, sales and pricing information in rows and columns, clearly stating the order of the data used. Here, we had to put our information in matrix form. But then, in matrices, they also told us to clearly state the order of the data used. Here, we have to state the order of the matrix. That is to say, row by column, row by column. So, the order of the supplies was 3 by 2. Then, for the prices is 2 by 1. Now, we are done with supplies. So, we are going for sales. A table showing the sales made by the supermarkets at the end of the month. We have our supermarkets here. Mega Supermarket sold 22 bales and 8 bags. Then Quality Supermarket sold 28 bales and 4 bags. Where is this 4 coming from? Remember in our scenario, they told us that in addition, 2 bags were damaged during storage and could not be sold. So you get these 6 bags of ours which were given to Quality Supermarket in the first place. You remove the 2 bags which were damaged, remaining with 4 bags, which are these ones that you have put in the table. Then Capital Shoppers Supermarket sold 14 bales and 11 bags. Then the prices are also here. This is 95,000 shillings and 250,000 shillings. Then you formulate the matrices for sales together with their prices. Matrices for sales with their prices. Here are the sales. Mega Supermarket 22 bales and 8 bags. Quality Supermarket 28 bales and 4 bags. Capital Shoppers 14 bales and 11 bags. The prices were the bales 95,000 shillings, bags 250,000 shillings. Then we go to the order of the matrix. order of the matrix for sales. It is row by column, which is 3 by 2. Then the order of the matrix for prices is 2 by 1. That marks the end of our part A. I think there is no need of conclusion because they just told us to organize the supply, sales, and pricing information in rows and columns, clearly stating the order. So we have finished stating the order and we have also finished to organize them, sales, supplies, and pricing. Now we go to our part B. They are telling us that we prepare the monthly review report required by the finance and hence advise the company on the allocation of sugar stock for the following month and give reasons for your answer. Our part B, to get part B, we are supposed to get these supplies, the matrices for the supplies together with their sales, and then we multiply them. Multiplication of matrices, which is row by column. Here we got 25 times 80,000 plus 10 times 220,000, which is here. Then you get 30 times 80,000 plus 6 times 220,000. You get 15 times 80,000 plus 12 times 220,000. Then 25 times 80,000, it's 2 million plus 10 times 220,000, which is 2,200,000. Then we also get 30 times 80,000, which is 2,400,000 plus 6 times 220,000, which is 1,320,000. Then 15 times 80,000 plus 12 times 220,000, giving us 1 million times 200,000. Sorry, 1,200,000 plus 2,640,000. When you get 2 million plus 2,200,000, you get 4,200,000. Then when you add this, you get 3,720,000. When you get this, you get 3,840,000. Now we go to our sales. You get, again, you multiply row by column because we already have the matrices for the sales with their prices. So you get 22 times 95,000 plus 8 times 250,000. Then you get 28 times 95,000 plus 4 times 250,000. 14 times 95,000 plus 11 times 250,000. When you get 22 times 95,000, you get 2,090,000 plus 8 times 250, which is 2 million. Then when you get 28 times 95, it's giving us 2,660,000 plus 4 times 250,000, which is 1 million. Then 14 times 95,000, it's giving us 1,330,000 plus 11 times 250,000, which is 2,750,000. When you add this, you get 4,090,000. When you add 2,660,000 plus 1 million, you get 3,660,000. When you add 1,330,000 plus 2,750,000, you get 4 4,080,000 shillings. So, Part B was telling us that we should prepare the monthly review report required by the finance manager, hence advising the company on the allocation of sugar stock for the following